All right, everyone. Thank you so much for coming to ETH Seoul. For our first speaker, we have Adash from Gnosis Chain. He'll be doing a talk on Gnosis Chain overview. And I'll let him take it from here.
Hello guys, I'm Adarsh from Gnosis Chain, and this session is on the introduction to Gnosis Chain and an overview of the Gnosis Chain. So what are we going to cover in this session? So what exactly is Gnosis Chain, an overview of it, why you should consider building on Gnosis Chain, how to build on Gnosis Chain, we'll go over a guide to deploy an app, and finally overview of our bounties, which we have tons of. Then finally going over some resources for the validators and developers alike, and wrapping up with the questions and how you can contact us later. So to get started, what is Gnosis Chain? So it's a layer 1 blockchain, which is 100% EVM compatible, which means you can just deploy your apps as you would do it on Ethereum, and it will work without any changes. And we follow Ethereum development roadmap pretty strictly. One of the examples is Ethereum recently changed to proof of stake consensus, and we previously adopted a proof of authority consensus, and we also have changed it now to a proof of stake consensus mechanism. We use a dual token system, one for gas and one for staking. And XDAI, which is used for gas, is a stable coin which is tied to the DAI on Ethereum, and that means you get stable prices for your gas. And it's highly decentralized. We are the second most decentralized chain out there, right after Ethereum, and we plan to increase our decentralization with not just the number of nodes, but also the different countries in which the node operators are present. And you can, since it's very closely followed by Ethereum, that means that it's highly intuitive. If you can use Ethereum, you should have no issues in using Gnosis chain. And we provide a lot of familiar toolings and development guidelines for you to do that. And we have a very robust and very fastly growing ecosystem to help you on your way for development. Our goal, as I said, is to become the most decentralized chain out there. One of the approaches that we use there is to reduce the barrier of entry. You just need one GNO to start staking and act as a validator, as compared to 32 ETH from Ethereum. And along with that, we have dedicated channels for our validators where you can reach out for any issues, and we reply promptly. Here are some stats from a Gnosis Metrics website. On the Gnosis Metrics website, you can get the transactions, stats, gas, accounts, etc., and all the information for the last 30 days. Here are just some of the stats for the last 30 days here. Here's a snapshot of some of the applications and tools from a vast ecosystem. Now, as a developer, why you should consider building on Gnosis chain? It has lightning fast speeds. For an L1, just a block time of 5 seconds. It's highly affordable. In just 0.01x or just 0.1 cent, you can do hundreds of transactions. It's highly accessible, as I previously mentioned as well. We have tons of guidelines and development tools, which should be quite familiar with anyone using Ethereum, and strong ecosystem support. And about the decentralization as well. The second most decentralized chain out there. We plan to be the first one too. Now, in the next few slides, I'll go through some of the popular projects on Gnosis chain. Starting off with the DAOs. Gnosis chain is actually one of the top choices for DAOs. Some of the most popular ones are the Cow DAO, which is for the cow swap, our own DAO, the Gnosis DAO, Bioeconomy, and the H1 Hive. We have tons of DeFi projects as well on our built over our chain. Some of the popular ones are Curve Finance, 1inch Desk, and BowSwap. You might also want to check out the NFTs and the gaming projects built on top of Gnosis chain. One of them, quite popular one, is POAP, which is a proof of attendance protocol, and I'll come back on it later on too. There's the Nifty Fair, Nifty Marketplace, sort of similar to OpenSea. We have lots of popular real-time strategy games. Maybe some of you might have heard of Conquest ETH. It's quite popular. And there's GitPop as well, which gives you digital badges for your GitHub contributions. Now, going over how, as a developer, you can get started building on the Gnosis chain. So the first step is just to get a wallet that supports Gnosis chain. We have a website dedicated for it, which allows you to select the wallet that suits your needs the best. Maybe you want an open source wallet or a self-custody wallet. You can filter the available wallets with those criteria, and then you get the wallet. After that, just connecting your wallet to the Gnosis chain. Here's the RPC endpoint provided for both the mainnet and the Chiado testnet. And alternative is to use autoconfig using chain list, and you can just automatically connect your wallet to Gnosis chain and Chiado. Now you've got the wallet, you have connected it with our RPC endpoint. Finally, you need XDAI for gas. So you get XDAI using a faucet. This is a faucet which provides you the XDAI for both the mainnet as well as the Chiado testnet. And you can just get your XDAI from there. To summarize the build process and the deployment process on Gnosis, it's very similar to Ethereum. And so it's 100% compatible with Ethereum. So if you can deploy it on Ethereum, it should be a cakewalk for you to deploy it here. Just follow the guidelines present. First, get a wallet, connect to the RPC endpoints, get XI from the faucet, and just deploy it. You can deploy it on the Chiado testnet as well, but if you, for the hackathon, you can directly deploy it on the Gnosis chain as well. There's no issues on that. So let's quickly go over the toolings for the validators. To start, we have D14N, which is a real-time dashboard for which measures decentralizations between Ethereum and the Gnosis chain. You can find stats like the number of node counts, the total staking, where the node operators operate from which countries, and which cloud providers do they use, information on staking pools, etc. And you can find a breakdown for all of them for Gnosis chain and for Ethereum, a side-by-side comparison for both. There's also the validategnosis.com, which is a how-to guide for selecting validators. So if you are new to learning a validator, you can just input some of the information and answer the questions present here. And based on that, you can be provided with a pre-configured hardware, or we'll suggest you to run it on the cloud. Or if you do not have much technical experience, you can just suggest you to use a dedicated staking pool, or use a plug-and-play solution. So it's pretty easy. Just follow the questions here on the validategnosis.com, and you should be up and running to start a validator pretty soon. So as I mentioned, that the Gnosis chain is a operates on a two-token system. There's also a token for staking, which is the GNO. So you can buy some GNOs from the BuyX. It's an aggregator website which aggregates all the possible most popular platforms where you can buy XDAI, and also the GNO. And based on your preferences, you want to use a fiat or crypto swap, etc. You want to use a bridge, you can just fill in this information and provide you all the popular providers where you can buy the GNO. Finally, there's one more thing that is one of our programs that we want to introduce, and that is the Gnosis VIP program, which is the Validator Incentive Program. So the idea here is that we don't only want large number of validators, but we also want diversity in the number of countries in which those validators operate in. So to encourage the diversity of the node operators, we have launched this validator diversity, the geographic diversity program, Gnosis VIP. So we are offering 5 million in bounties, which will be provided to you in GNO. We already have validators from over 75 countries, and we plan to we target a lot more. And our mission, as I previously mentioned, is to be the most decentralized chain out there. We are the second one right after Ethereum, and the barrier of entry is quite low as well. It's just one GNO. Here is a QR code you can scan to visit the Gnosis VIP, the gnosisvip.com, and get started with the bounties. Some of our other bounties that we have is, which I'm going to go over next. Starting off with the Hashi project, which is a project built by the Gnosis Guild team. It's a cross-chain protocol based on additive security. So at its core, Hashi is a hash oracle aggregator, so which allows developers to build, which allow developers to use the best options available and get the best out of all worlds for using the dexes and bridges. So the idea is to what we call a redundant array of hash oracles. The main goal here is to distribute the trust so that you don't have to trust any particular bridge security mechanism, but you can get all of those. And the reason why we decided to build this was, why was it necessary? So just in 2022, last year, if you check the Rect news, top 4 out of 5 Rect leaderboards were actually bridge exploits. So you cannot trust any individual bridge because no bridge is 100% secure. So this allows the users to create a layer of additional security on top of that. So the idea is that why choose one bridge when you can, bridge security mechanism when you can have all of them. And all the bridge designs have different trade-offs maybe for costs, securities, and audit, so you can get the best of all worlds here. Now, there are some projects that we would like developers to build on top of Hashi. That includes maybe writing an adapter for another bridge or a ZK client. And there's some improvements that we would like you to make on Giri Bashi, which or new consensus mechanisms for when oracles disagree with each other, or build a governance bridge. And the end-to-end, some end-to-end applications on top of that. Apart from these two, just be as creative as you can and send us a proposal and we'll review it and get back to you. Yeah, some of the resources for building on, for some of the resources for Hashi. Now there's some other projects as well that we would like to discuss, and there are bounties for these two. So starting off with is a payroll EVM programmable bank account, a payroll with that, which is you can just brainstorm some solutions to improve the payroll mechanism, like maybe do some calculate the salaries, some taxes stuff, or some any other stuff. You can just brainstorm it, send us a proposal for the payroll for EVM programmable bank account, or may build with POA, which is the proof of attendance protocol. So turn your memorable moments into a digital collectible. There are some ZK bridge solutions that you might explore as well. End-to-end ZK bridge solutions on Gnosis chain. There's the Euro Ramp app, which is which allows users to invest their euros into crypto, and you can build apps on that too. It is powered by Monerium, which is a decentralized payment solution built on top of blockchains. And this will allow users to use the Safe app and invest the euros into different crypto assets. And finally, using the Li-Fi technology, which allows devices to connect even when they are at some distance. This will, and the same Euro price aggregator, we'd like to see that here, the Euro price aggregator on Gnosis chain using the Li-Fi technology. And yep. So these are some, this is what you can scan and look at the resources for the project requested. Finally, we'd love to hear from you if you can contribute to Gnosis chain in any other way, irrespective of whether you are a developer or a designer or just interested in blockchains or passionate to improve the Gnosis chain. We would love to hear from you. Just be as creative with your ideas as possible, and send us a proposal, and we'll take a look at it. And welcome to the decentralized journey with Gnosis chain. Sharing some resources now, which will for development. Starting with the docs, and this should be your entry point for the documentation on Gnosis chain. So all the developers, if you want to build on Gnosis chain, this is the entry point for you all. the buyxchai.com, which is the aggregator for both the xchai and the GNO. So yeah, this is where you can buy some xchai or GNO. There's also the MGNO validate Gnosis, which converts your GNOs to MGNO. MGNO is what you use to stake on the Gnosis chain, and this is the website that you can use to convert between these two. It's an MGNO is similar to wrapped ETH, and it's like the ratio here is 32 MGNO to 1 GNO. Here sharing some of our socials of how you can get in touch with our team. There's always Twitter where you can just tag us, and we monitor it pretty closely. We have our Discord channels where folks are pretty active. We have our dedicated Telegram channels, and you can always contact us on our website. Yep, that's all, and I would love to address some questions if you have. Okay, if there aren't many questions, maybe you can ask some questions on some resources or some bounties that we offer, and would love to address those too. Cool, in that case, would love to chat with you all at our booth, and we also have a PO up there, so we'll issue one for you if you just swing by us, and I would love to hear from you. Yep, that's all. Thank you.
Thanks, that was great. Next up, we have Scott from Near Protocol. He'll be doing a talk on BIDL without limits, removing every barrier to Web3 adoption. Yeah, you can connect it there.
Yeah, sorry for the delay. I was supposed to upload it here, but I just found out the link today, so sorry for the delay. Without further ado, my name is Scott Lee. I'm the general manager of Near Korea. I actually prepared the presentation in Korean because I think we're actually having this event in Korea. So I know there are a lot of developers that want to build on Near, so I decided to give a speech in Korean. So for those of you who do not understand Korean, sorry, but I'll just go ahead and speak in Korean. 네, 그래서 이번 이스 서울 행사에서도 이제 저희 일리아 이제 파운더인 일리아도 오셨고 이제 저희가 컨센서스 때 런칭한 버스나 이제 페스터스 같은 기능들을 더 자세하게 설명드리겠지만 저는 오늘 뭐 니어에서 이제 저희가 하고 있는 일들, 니어가 어떤 걸 하려고 그러는지 또 이제 니어에서 빌딩하실 때 어떤 점을 좀 주목하셔야 되는지 그리고 이제 저희가 어떤 거 뭐 웹3에서 어떤 걸 하려고 그러는지 좀 설명을 드리면서 오늘 프레젠테이션 마무리하려고 합니다. 네, 그래서 니어는 2020년도에 일리아가 이제 니어.ai라는 회사로 시작을 했고요. 원래는 이제 AI 쪽 그 요즘 뭐 챗GPT 때문에 좀 이제 엄청 뭐 핫해지고 있긴 한데 트랜스포머라는 기능에 이제 어텐션 이즈 올 유 니드라는 공동 저자입니다. 그래서 이제 원래 구글 AI의 스콜러였고요. 이제 원래는 니어 AI로 시작을 했다가 블록체인으로 피보팅한 케이스고 이제 왜 그러면은 블록체인을 시작했냐? 어쨌든 이 LLM을 할 때 이제 그 개인들에게 좀 보상을 주는 인센티브 구조를 블록체인으로 하면 좋겠다. 뭐 전 세계 여러 국가에 이제 많은 개발자들이 있는데 그들이 이제 컨트리뷰션을 할 때 그 인센티브를 어떻게 줄 수 있을까를 고민하다가 이제 이 니어 프로토콜을 만들게 됐습니다. 네, 그래서 저희 니어 재단의 C랩 엘들이신데요. 보시면은 웹2에 계셨던 분들도 많고 웹3의 경험을 가지고 계신 분들도 많고 그래서 웹2와 웹3의 경력을 모두 다 가지고 계시고 그래서 이제 웹2에서 웹3로 온보딩할 때 어떤 것들이 필요한지를 좀 잘 알고 있는 분들이 저희의 C레벨들이다 이런 점 좀 강조드리고 싶고요. 또 뭐 저희 재단 쪽에 BD를 총괄하고 있는 로비님은 트위치의 에이펙 헤드셨고 그래서 게이밍에 대한 이해도도 있고 웹2에서 어떻게 플레이어들 또 특히 게임 회사들이 웹3를 온보딩할 수 있을지에 대해서 좀 어드바이즈도 하고 저희가 같이 이렇게 좀 도움을 드리고 있습니다. 네, 그래서 뭐 아까 제가 처음에 시작할 때 말씀드렸지만 이제 일리아가 요즘 뭐 그 오픈 AI의 마피아라고 하더라고요. 그래서 어쨌든 그 어텐션에서 올린 니드라의 공동 저자들이 지금 나와서 이제 차린 회사들을 좀 보여드리고 있는데요. 뭐 거의 다 유니콘 수준의 AI 기업들을 다 만들어냈고 그 중에 유일하게 이제 니어 프로토콜이 블록체인 쪽에서 활약을 하고 있다 이렇게 말씀드리고 싶고요. 네, 저희는 그래서 어쨌든 이 니어는 지분 증명의 합의 방식을 가지고 있는 레이어 1 블록체인이고요. 샤딩을 이더리움보다 먼저 런칭했던 이제 체인이고 저희가 현재는 4개 샤딩이 돌아가고 있는데 뭐 올해 말까지 100개 샤딩이 돌아가게 되면 이론적으로는 한 10만 정도의 TPS를 달성하게 됩니다. 네. 네, 그래서 이제 저희가 확장하는 방식인데요. 이제 다양한 파트너십이나 우리 이렇게 이스 서울 같은 이제 이런 행사에 이제 참여하면서 이제 커뮤니티도 빌딩하고 그다음에 이제 여러 인프라스트럭처에 집중하면서 어쨌든 유저 경험을 개선하자. 이게 저희의 좀 방향성이라고 보시면 될 것 같습니다. 네. 그러면 니어가 지금 현재 그럼 쓰고 있는 어떤 그 지표들은 어떻게 될지 한번 좀 보여주는 좋은 장표인데요. 아까 제가 말씀드린 것 같이 4개 샤드가 돌아가고 있고 파이널리티가 사실 되게 중요한데 어쨌든 1, 2초 정도의 파이널리티를 가지고 있고요. 현재 2,500만 정도의 계정, 누적으로 2억 5천만 정도의 트랜잭션 그리고 현재 한 3,800명 정도의 액티브한 개발자들이 니어에서 계속 개발을 하고 있습니다. 네, 그래서 계속 뭐 저희 한국에서도 이제 저희가 어쨌든 개발자 생태계가 상당히 중요하다고 생각을 해서 이제 전국에 계신 각 학회들, 이제 대학 블록체인 동아리들이랑 저희가 협업을 맺고 얼마 전에도 저희가 글리치 해커톤에 이제 참여를 해서 저희가 이제 뭐 멘토링도 하고 이제 니어 트랙이 처음으로 이제 개최된 멀티체인 해커톤이었는데요. 이제 거기서 니어 트랙이 저희가 우승을 했습니다. 이제 그럴 정도로 저희가 좀 개발자 생태계에 관심이 많고 개발자들을 위한 지원이나 어떤 멘토링을 아끼지 않고요. 저희 이제 니어의 그 코리아에서 이제 좀 니어가 그럼 한국에서 어떤 점이 다르냐라고 할 때 이제 뭐 개발하시다가 좀 궁금한 점이 있으시면은 저희 니어 디스코드 방에 들어오시면 저희 이제 풀스택 개발자들이 다 답변을 해드립니다. 그래서 개발할 때 좀 어려우신 상황이나 어떤 그런 게 있으면 티켓을 발행하고 거기에 대한 질문들을 주시면 저희가 바로바로 답변을 해드리고 있고요. 그 니어가 그러면 지금 현재 상태가 어떻냐라고 하시는데 저희가 누적 투자액은 한 7천억 정도 좀 받았었고 지금 현재 이제 이 니어에 있는 에코시스템 펀드라고 해서 이제 니어에 온보딩하는 이제 그 뭐 프로젝트에 투자도 하고 그런 생태계 펀드만 한 800 밀리언 정도 있고 약 한 뭐 1.23조 원 정도 되는 규모의 펀드를 가지고 있다 이렇게 이해해 주시면 될 것 같고요. 니어는 이제 뭐 보시면 아시다시피 되게 유수한 탑 티어 VC들한테 이제 그 투자를 받은 그런 체인입니다. 그래서 뭐 보시기만 해도 아시겠처럼 뭐 에이스엑스인지나 뭐 반테라나 해시드 그다음에 뭐 그냥 보시면 아실만한 그 또 서클 같은 곳들이 저희에게 이제 투자를 했던 체인이고요. 그래서 이제 저희 니어는 한국에서는 이 4가지 목표를 가지고 좀 미션을 가지고 좀 활동을 하고 있습니다. 그래서 어쨌든 저희가 이제 일본까지 좀 커버를 하면서 다양한 양질의 프로젝트를 많이 온보딩하고 특히 게임이라든지 엔터테인먼트 IP 어쨌든 유저를 가지고 있는 뭐 다양한 좋은 양질의 프로젝트를 많이 올리자. 그래서 이게 첫 번째 목표고요. 두 번째로 이제 개발자들이 생각할 때 내가 웹3 어떤 프로덕트를 만들고 싶은데 어디다 개발을 하지라고 할 때 바로 떠오를 수 있는 탑 오브 마인드 레이어 1이 되는 게 또 저희의 목표, 두 번째 목표입니다. 그리고 세 번째로 저희가 이제 지금 계속 하고 있는데 어떤 대기업과의 파트너십이라든지 뭐 다양한 게임사, 엔터테인먼트 회사와의 이제 파트너십을 통해서 저희 브랜드 어웨니스를 좀 제고하는 것들. 이제 마지막으로 저희가 올해 말 정도에는 아마 니어 에코시스템 펀드라고 이제 코리아에 좀 집중하는 펀드를 만들 텐데요. 이제 뭐 저희가 체인 애그노스틱하게 하는 부분도 있을 거고 니어에 이제 온보딩되는 프로젝트에 투자를 할 텐데 어쨌든 저희가 펀드를 가지고 좀 진짜 이 한국 시장에 진심이다라는 걸 좀 보여주면서 저희가 이제 활동을 하려고 하고 있습니다. 니어가 해외에 진출하는 방식은 좀 독특합니다. 그래서 이제 니어는 보통 해외 진출을 할 때 뭐 어떻게 보면은 그 재단 쪽이나 뭐 어떤 본사에서 누구를 파견해서 뭐 지사장이나 지사를 파견하는 게 아니라 그 현지에서 잘하고 있는 플레이어들과 파트너십을 맺고 하는 거고요. 그래서 이제 제가 이제 니어랑 얘기했을 때도 이런 다양한 전 세계에 이런 니어 허브들이 있는데 리저널 허브들이 있는데 이제 저희가 한국뿐만 아니라 인도나 베트남, 그다음에 뭐 케냐, 그다음에 발칸이라고 해서 동유럽 쪽, 그다음에 이제 미국에서는 뭐 니어 US라고 이름을 활동하지 않고 이제 반얀이라는 이름으로 활동을 하고 있습니다. 그래서 이제 다양한 좀 이제 활동들을 허브를 통해서 하고 있고요. 저희가 하는 역할은 이제 아까 말씀드렸다시피 이런 미럽 같은 데나 이제 이런 행사에 뭐를 개최하기도 하고 저희가 참여하기도 하고요. 그다음에 이제 아까 저희가 학회 지원 드리는 것처럼 개발자를 양성하거나 뭐 이런 저변을 확대하는 일들을 많이 하고 이제 사업 개발, 마케팅 지원 같은 것도 많이 하고 있고 여전히 저희는 좀 액티브하게 그랜트도 드리면서 프로젝트를 온보딩할 수 있게 도움을 많이 드리고 있습니다. 네, 네, 니어는 사실 이제 웹3 기업이라고 하기에는 상당히 웹2스러운 프로덕트를 만들고 있다고 좀 말씀드릴 수 있을 것 같습니다. 지금도 사실은 뭐 제가 이트 서울에서 하는 말은 좀 그렇지만 메타마스크 지갑을 사실 일반 유저들 웹3 경험이 전혀 없는 유저들한테 깔려 그러면 이거 자체가 허들이거든요. 시드 프레이즈를 뭐 외워야 되고 니모니 키를 저장을 해야 되고 그다음에 이제 키를 만약에 잊어버렸다라고 했을 때 내 자산들이 좀 뭐 없어지거나 뭐 이게 탈취당할 수도 있는 어려움들이 많은데 저희는 그런 것들을 좀 보완하기 위해서 다양한 방법들을 좀 고안해 내고 있습니다. 그래서 이 후반부에 좀 더 설명을 드리겠지만 간단하게 말하면 저희는 그냥 이메일 계정 같은 이제 주소 체계를 좀 가지고 있고 그리고 이제 좀 독특한 키 구조를 가지고 있습니다. 네, 그래서 이제 저희는 펑션 콜키라고 하는 어떤 그 키 구조를 가지고 있어서 어떤 특정 서비스나 기능만 수행하는 펑션 콜키를 발급하고 뭐 그것들을 이제 복수로 생성한다든지 제공한다든지 아니면 삭제할 수도 있고 이런 구조를 통해서 뭐 가령 예를 들면 게임사가 뭐 어떤 유저가 이제 어떤 행동을 할 때마다 서명을 하는 게 아니라 그 트랜잭션을 날릴 때마다 이제 서명을 하는 것들을 이제 펑션 키를 게임사에 위임을 하고 이제 어떤 게임 회사에서 이제 온 트랜잭션 서명을 할 때마다 이제 뭐 서명 페이지로 넘어가지 않고 자연스럽게 웹2 게임 하듯이 이제 할 수 있다는 그런 유즈 케이스들이 좀 많이 나오길 기대하면서 지금 게임사랑 활발하게 얘기를 하고 있고요. 그래서 이런 것들을 잘 활용하게 되면 뭐 이제 저희가 메텐스 트랜잭션이라는 기능도 있는데 어떤 가스비를 좀 대납을 해서 이제 유저들이 온보딩할 때 가스비를 내지 않아도 서비스를 좀 심리싸게 사용할 수 있는 경험들을 다양한 이런 키 구조를 통해서 좀 제공을 하고 있습니다. 그리고 좀 마지막으로 말씀드리면 저희는 월렛이 없어도 온보딩할 수 있는 기능도 갖추고 있습니다. 네, 그래서 뭐 저희가 어쨌든 그 웹3를 온보딩하기 위한 모든 허들들을 다 없애버리겠다라는 좀 미션을 가지고 다양한 또 피처들과 이제 파고다에서도 열심히 개발하고 계시고 저희 일리아님도 열심히 하고 계시는데 어쨌든 이런 이제 저희가 컨센서스 때 이제 런칭했던 버스라는 개념 자체도 어떤 프론트엔드 단에 탈중앙화된 프론트엔드를 만들어서 사실 이제 뭐 왜 그러면 니오로 쓰게 해야지 왜 다른 이런 걸 만들고 있는 거라고 생각하실 텐데 어쨌든 다양한 멀티 체인들을 좀 받을 수 있는 어떤 프론트엔드 단에 유저가 그냥 다른 체인들에 계속 로그인 할 때마다 다른 지갑을 쓰는 게 아니라 한 지갑에 서명을 했을 때 다른 여러 가지 뭐 디파이를 서비스를 쓴다거나 게임을 한다거나 뭐 토큰 수합을 한다거나 이런 것들을 그냥 한 그 플랫폼 안에서 이제 할 수 있는 것들을 저희가 좀 구현을 하고 있다 이렇게 이해해 주시면 될 것 같고요. 그래서 저희 뭐 보스는 이 후반부에도 저희 뭐 맷이나 이제 뭐 MJ나 이제 저희 내일에도 이제 일리아가 좀 자세하게 다루실 거라서 영어로 요 부분은 뭐 좀 그냥 스킵하도록 하겠습니다. 네, 뭐 어쨌든 아까 제가 말씀드린 대로 이 보스를 사용하면 다양한 서비스를 그냥 한 곳에서 쓸 수 있다라는 게 핵심입니다. 네, 그래서 뭐 뒤에 니오가 붙어있던, 이더리움이 붙어있던, 아발란치가 붙어있던 상관없이 폴리곤이 붙어있던 프론트 단에서 그냥 내가 로그인하고 계정한 서비스를 그냥 이용할 수 있다. 이게 핵심이고요. 네, 그래서 아까도 제가 계속 강조드린 것처럼 저희는 이제 매스 어둠션을 방해하는 모든 요소들을 제거하고 어떻게 하면 사실 이 웹2 유저들을 웹3로 데려올 수 있을까에 좀 상당히 집중하고 있는 체인이어서 이제 그런 것만 고민하면서 뭐가 필요할지, 그래서 뭐 아까 제가 말씀드린 대로 뭐 패스터스라든지 보스라든지 이제 저희 뭐 니어 지갑 같은 경우도 이제 휴먼 리더블 애드레스, 뭐 이더리움에서는 이제 계정 추상화라고 하는 어카운트 앱스트랙션 같은 거를 이미 디폴트로 내재화했다. 그래서 그런 것들을 이미 피처들을 가지고 있다, 이렇게 해주시면 될 것 같고, 그래서 뭐 저희가 그러면은 웹3의 어떤 UX를 개선하기 위한 기능들이 뭐가 있냐라고 하면 이 세 개로 압축될 것 같습니다. 아까 제가 말씀드린 대로 이메일 같은 계정, 뭐 가령 제가 scott.near를 그냥 이렇게 생성할 수 있듯이 제 지갑이 그냥 이메일처럼 되듯이 그냥 그렇게 할 수 있고, 이제 아까 제가 말씀드린 펑션 콜 키나 이제 저희의 그 풀 액세스 키 같은 그 키 계정 구조를 활용한 다양한 기능들, 그다음에 이제 제로 피 트랜잭션, 이게 메타 트랜잭션인데 어쨌든 서비스사가 어떤 유저의 가스비를 대납을 해서 유저가 가스비를 내지 않고도 서비스를 이용할 수 있게끔 하는 기능들, 이런 걸 잘 활용하면 이제 결국에는 어떤 저희는 지금 웹 2.5를 지향하고 있다고 하는데 웹2 유저들이 웹3로 많이 넘어올 수 있지 않을까, 어떤 메인스트림 어답션을 만들 수 있지 않을까, 이런 기대를 하면서 네, 다양한 기능들을 계속 고도화하고 있습니다. 네, 뭐 아까 제가 말씀드린 패스터스 기능입니다. 이것도 그냥 여러분 뭐 지금 다양한 웹2 앱에서 그냥 지금 아이폰으로 그냥 쓰고 계신 것처럼 그냥 이메일 생성하면 이메일에 이제 지갑 주소가 매핑이 돼서 바로 그냥 계정이 생성되고요. 이게 이제 뭐 당연히 블록체인 상에 원 트랜잭션으로 기록이 되고, 이제 사실 제가 이제 그 어떤 제 계정을 잊어버릴지라도 MVC 기능을 통해서 이제 계정 복구가 가능한 어떤 뭐 싱글 사인온 같은 웹2의 그냥 로그인 기능을 저희가 구현했다, 이렇게 이해해 주시면 될 것 같습니다. 그리고 이제 뭐 이것들에 대한 활용 사례가 엄청 많아질 거고요. 어쨌든 이메일 하나로 내 지갑 계정까지 만들고 서비스를 그냥 다양한 서비스를 한 플랫폼에 어떤 다른 체인으로 옮기지 않고도 쓸 수 있다라는 게 큰 장점일 것 같고요. 뭐 아까도 말씀드린 이제 그 기능이고, 저희가 이제 아까 제가 말씀 안 드린 기능이 도메인 영역의 커스터마이징까지 좀 가능한 기능들이 있는데, 예를 들어 뭐 가령 뭐 제가 scott.near라는 이제 계정을 만들었는데 뭐 제가 예를 들면 뭐 어디 여기가 롯데, 뭐 롯데가 이제 저희 니어 구조 계정을 사용하고 싶다 그러면 이제 scott.롯데 뭐 이렇게 할 수도 있습니다. 그래서 이제 그런 것들을 저희가 이제 재단이랑 그 동의하에 이런 커스텀 기능까지 이제 제공을 하고 있고요. 네, 아까 이제 제가 말씀드린 키 기능인데 뭐 이런 키 구조를 이용을 해서 뭐 어쨌든 그러니까 예를 들어드리면 저희가 뭐 스타벅스를 가는데 집문서라든지 은행 통장을 가지고 가지 않잖아요. 인감증명을 가지고 가지 않잖아요. 그런 것처럼 특정 기능을 사용할 때는 뭐 그냥 진짜 애플페이나 뭐 그냥 삼성페이만 들고 가듯이 펑션 콜 키만 가지고 어떤 특정 수행만 기능을 활용하고 이제 뭐 필요가 없다면 소각을 해버린다든지 제거를 해버린다든지 이런 구조를 통해서 뭐 어떻게 보면 이제 유저의 어떤 자산에 대한 어떤 안정성과 보안성, 이런 것들을 좀 고치시키고 이제 그런 안정성도 가져가면서 뭐좀 다양한 서비스사들도 좀 고민 있는 부분들을 이 키로 활용할 수 있겠다. 이런 다양한 활용 사례가 아마 이제 올해 하반기부터 다양하게 좀 많이 나올 것 같습니다. 네, 아까 제가 말씀드린 이제 메타 트랜잭션이라는 제로피 트랜잭션이고요. 네, 뭐 그래서 여러분 지금 그냥 바로 니어.5 들어가시면 사인업해서 그냥 다 써보실 수 있습니다. 사인해서 이메일 계정 넣으시고 니어 계정 만들고 여기 있는 지금 다양한 게임이라든지 디파이 서비스들 지금 이미 뭐 연동돼 있는 디파이 서비스들도 좀 있는데 이런 거 활용해 보시면서 이게 이렇게 쉽나라는 걸 좀 한번 경험해 보시면 좋을 것 같고, 또 이번 ETH 서울에 참가하시는 분들은 이 보스를 활용해서 또 다양한 뭐 어떤 프로덕트라든지 이 안에서 이제 서비스를 좀 만들어 보면 좋겠다, 이런 말씀 좀 드리고 싶습니다. 네, 뭐 제가 항상 그러면 그 니어 위에는 어떤 서비스를 돌아가고 있어? 이런 구조들, 이런 키 구조나 뭐 이런 너희가 지금 얘기하는 되게 쉬운 어떤 사인인 그런 기능을 통해서 어떤 서비스를 구현하고 있어라고 하면 저는 단연코 스웨코인을 좀 사례로 들고 있긴 합니다. 그 한국에서 생각해 보시면 캐시워크 같은 이제 앱인데요. 뭐 걸을 때마다 보상을 주고 이제 뭐 서비스를 하는 그런 기능인데, 가령 여러분 기억하실 텐데 스태프니 그냥 전체 유저가 다 10만 명이었거든요. 저희는 지금 뭐 이 회사는 거의 2007년부터 이제 이 서비스를 운영하던 회사고 전 세계 60개국에서 1위를 하고 있는 앱이고요. 지금 뭐 등록자 유저 수만 한 1억 2천만 명, 그리고 이제 작년 9월에 저희 니어에 온보딩을 했는데 이제 온보딩하면서 전환된 지갑 생성수만 한 2천만 개입니다. 그래서 뭐 여러분 약간 안 와닿으실 텐데 이 넘버가 그럼 어떤 숫자냐? 제가 좀 그냥 간단하게 비교를 해보면 여러분 그냥 생각하실 수 있는 USDC나 USDT 홀더들이 한 뭐 460만, 180만 정도 있는데요. 지금 스웩 코인의 홀더 수만 한 1,000만 명이 넘습니다. 그리고 이 지금 이 MAU 기준으로만 이제 뭐 거의 100만 명 기준이고요. 그리고 이제 웹3 사용자 수, 이 스웩 코인의 서비스를 사용하고 있는 뭐 사람 수만 2천만 명이 넘습니다. 그래서 이게 지금 잘은 모르실 텐데 어쨌든 싱글 뎁으로서 글로벌 넘버원 앱입니다. 그래서 이 많은 어떤 트랜잭션과 볼륨을 일으켜도 뻗지 않고 이 트랜잭션을 받을 수 있는 체인은 니어가 가능하다. 저희가 샤딩 블록체인이기 때문에 이런 게 가능하다는 말씀 좀 드리고 싶고요. 그래서 뭐 구조는 간단합니다. 이게 뭐 걸을 때마다 제가 5,000번으로 걸으면 이 포인트가 이제 그 로컬 서버에 저장이 되게 되고 이제 이 포인트를 제가 원할 때만 이제 스웨트 월렛이라는 앱이 있고 거기 이제 액티베이션 되면서 이제 내 지갑이 생성이 되면서 그 스웨트 포인트를 이제 토큰으로 전환할 수 있는 구조를 가지고 있고요. 제가 이제 이거 보면서 이제 되게 그 이 CEO가 되게 똑똑하다고 생각을 한 게 어쨌든 이 스웨트를 다운로드 받으려면 구글 플레이 스토어나 이제 뭐 애플 앱 스토어에서 이제 받아야 되는데 거기에 지갑이나 이제 토큰이 좀 연동이 돼 있으면 이제 이게 디리스팅 될 수 있는 가능성이 있으니까 지갑은 아예 따로 패놓고 이런 내가 그냥 일반 유저들은 사실 이거 걸으면서 그냥 보상을 받으면 이 뒤에 웹3 블록체인이 있는지도 모르고 이제 쓰다가 이제 내가 원할 때만 지갑이 액티베이션 되면서 다양한 기능들을 좀 쓸 수 있는 구조들을 만들었다. 이런 점에서 되게 좀 잘하고 있다고 생각이 들고요. 그리고 이제 스웨트이 또 잘하고 있는 게 그 안에서 뭐 런투원이라든지 좀 다양한 재밌는 뭐 어떤 서비스를 좀 계속 내놓고 있습니다. 그리고 이제 게이미피케이션 또 계속 입히고 있어서 내가 뭐 누구랑 이제 뭐 어떤 컴피티션을 도전을 신청을 해가지고 일주일 안에 누가 더 많이 걷냐, 뭐 하루에 누가 더 많이 걸었냐, 한 달 안에 누가 더 많이 걸었냐 이런 것들을 좀 뭐 이렇게 배팅을 걸고 이렇게 좀 게임을 할 수 있는 피처들도 지금 계속 만들고 있고요. 그리고 이제 이 스웨트에 있는 유저들도 다른 서비스도 좀 쓸 수 있게끔 연동하는 그런 작업들을 좀 스웨트에서 계속 하고 있습니다. 네, 그리고 이제 저희 쪽에는 영국에 있는 플레이엄버라는 게임사가 있습니다. 그래서 이제 그냥 생각해 보실 때 그냥 게임사인데요. 어쨌든 이제 웹2에 있는 하이퍼 캐주얼 회사들이 웹3로 쉽게 넘어올 수 있는 SDK를 개발하고 어떤 프리투윈 모델의 그 광고를 보면서 보상을 받는 구조를 웹3에서도 구현했다. 이렇게 보시면 될 것 같고 여기가 어쨌든 디세이블 리텐션이 이걸 깔았을 때 100% 상승하는 좀 효과들을 많이 보고 있고요. 지금 점차적으로 많은 회사들이 이 플레이엠버가 만든 솔루션을 좀 쓰기 시작하고 있다. 이렇게 이해해 주시면 될 것 같습니다. 네, 그래서 저희가 최근에 좀 온보딩한 회사들이 좀 많습니다. 그래서 좀 다양한 영역에서 뭐 커머스라든지 니시는 특히 그 틴더 파운더가 만든 소셜 웹3 소셜 앱이고요. 그다음에 이제 뭐 다양한 각 전 세계적으로 유명한 회사들이 계속 이제 온보딩을 하고 있고 뭐 슬릭이라는 거는 이제 NBA 전 스타 베런 데이비스가 만든 서비스인데 어떤 저작권 이미지 자체를 좀 올리고 거기에 보상을 받는 그런 서비스고 이제 아까 또 이제 이따 나와서 메시 얘기했지만 키펌이라는 서비스도 있고요. 그리고 저희가 이제 좀 다양한 백커들과 좀 그 큰 대기업들과 또 파트너들과 다양한 재밌는 서비스를 좀 만들고 있다. 이렇게 좀 생각해 주시면 될 것 같고요. 특히 저 세일즈피라는 곳은 그 전 오라클 회장님이 좀 만드신 그 다오 구단인데 이제 요트를 어떻게 보면은 구단 자체를 좀 다오화 해가지고 전 세계 최초로 구단을 다오화시키는 프로젝트입니다. 그래서 그것도 니어에서 지금 만들고 있고 어쨌든 팬들이 보팅을 하고 뭐 어디 대회 참가할지 어떤 선수를 출전시킬지 이런 것들을 투표를 통해서 이제 운영을 하게 되는 최초의 다오 구단이라고 생각해 주면 될 것 같고 그런 것들이 계속 지금 좀 리얼 유스 케이스를 만들면서 니어에서 재밌는 서비스를 하고 있다 이렇게 이해주시면 될 것 같고요. 네 그리고 뭐 니어는 다양한 전 세계 탑 티어 거래소에도 다 상장이 돼 있고 뭐 바이낸스나라든지 다른 다양한 빅코라 같은 커스터디 서비스도 지원을 하고 있고 다양한 체인 애널리틱스랑도 다 연동이 돼 있습니다. 네, 아까 제가 말씀드린 다오 구단이고요. CLGP라고 하는 구단인데 여기가 이제 니어에서 어쨌든 NFT로 뭐 티켓팅도 할 수 있고 참가할 수 있고 제가 뭐 보팅을 해서 어떤 펀딩과 거버넌스를 어떤 내가 팬들이 좀 운영할 수 있는 다오 형태의 최초 구단이다 이렇게 이해해 주시면 될 것 같고요. 드랍들하고 이제 NBA 팀들과 함께 어떤 브랜드라 스포츠 팀들이 자체적으로 좀 운영하는 로열티를 관리해 줄 수 있는 그런 솔루션을 좀 제공하고 있는 드랍트라는 회사고 여기도 이제 저희의 온보딩을 해서 열심히 좀 솔루션을 만들고 있고요. 네, 솔레어라고 이제 뭐 웹3 피지털이라고 하는데 실제 물건과 NFT가 매칭돼서 뭐 이것들을 내가 거래할 수도 있게 하고 뭐 이런 이제 실제 실물 기반의 좀 NFT 이렇게 생각하시면 되는데 이런 것들이 다양한 패션 회사들과 지금 좀 파트너십을 맺으면서 또 니어에서 열심히 빌딩하고 있습니다. 네, 그래서 뭐 이번에 니어 트랙 좀 간단하게 그냥 소개드리면 뭐 오늘부터 이제 시작을 하는 거고 저희는 이제 매스 어덥션을 위한 실제 생활에서 일상생활에서 쓸 수 있는 많은 사람들이 쓸 수 있는 좀 매스 어덥션을 위한 뎁들을 좀 우선적으로 목표로 좀 트랙을 걸었고요. 그래서 뭐 러스트라든지 저희는 이제 자바스크립트 개발자도 그냥 SDK를 통해서 스마트 컨트랙을 빌딩할 수 있습니다. 그러니까 뭐 러스트 랭귀지를 모르셔도 자바스크립트 통해서도 이제 할 수 있고 오로라를 통하면 EVM에 기반해서 이제 저희가 니어의 스마트 컨트랙 배포할 수 있고 개발할 수 있는 환경이 갖춰져 있어서 그래서 여기서 좀 어떤 매스 어덥션을 위한 다양한 뎁들이 이번 ETH 서울 해커톤을 통해서 좀 많이 나왔으면 좋겠습니다. 네, 이상 마치겠습니다. 감사합니다.
All right, next up we have Swan from Evmos. She'll be doing a talk on building with EVM extensions.
네, 안녕하세요. 에브모스에서 현재 풀스택 팀을 리드하는 프로덕트 매니저 김수환이고요. 제가 에브모스에 들어온 지 한 3개월 반 정도 되거든요. 네, 그래서 제가 들어왔을 때 팀들이 이렇게 너무 좋아하는 거예요. 이렇게 한국 사람도 들어오고 이렇게 되면 이제 한국에 있는 팀들도 너무 다양하고 아주 탤런티드한 웹3 커뮤니티가 이제 좀 뜬다고 이렇게 한국 사람들이랑 한국말도 하고 통역도 하고 이런 한국의 이벤트에 오면 이렇게 한국어로 이렇게 프레젠테이션 하는 것도 하면 얼마나 좋겠냐고 이렇게 하는데 이제 들으시다시피 제가 한국말을 좀 잘 못해요. 그리고 못하면서도 경상도 사투리가 너무너무 세요. 예. 그래서 제가 그 어렸을 때 한국에서 나와가지고 한국말은 조금은 하는데 근데 뭐 이런 프레젠테이션 할 때 이렇게 한국말로 이렇게 메인이 되는 게 아니고 영어로 먼저 메인을 하고 뭐 한국말 이렇게 조금씩 이렇게 넣어서 제가 프레젠테이션을 해볼게요. 예, 그래서 이제 다음에 만날 기회가 되면 제가 좀 더 준비되어 있는 한국말로 이렇게 좀 제가 준비를 해놓을게요. 그래서 그래도 제가 한국에 와가지고 한국 사람으로서 한국말로 이렇게 인사는 드리고 싶어서 제가 좀 열심히 좀 준비를 했어요 한국말을. 그래서 그럼 영어로 그냥 진행을 할게요. Okay, cool. So hi everyone, I'm Swan. Sorry for that. I'm Swan. I wanted to do a quick intro in my broken Korean to my Korean-speaking community. So anyway, so I am a product manager at Evmos for the full stack team. Our team works on working on basically building out the best user experience for everyone using Evmos, everyone who can interact with Evmos, more specifically our dashboard, but not limited to it, because as you use your tokens, like your user experience is in and out of web applications, right? So today, I will be giving you an overview of EVM extensions, what they are, what they mean to you as developers, what they mean to end users, and also review some use cases that we have in mind that we've already implemented so that you can also see how you can put it into practice. But before that, let me actually get into Evmos itself for those who need a reminder or for those who need a re-reminder. Evmos, if you don't know, Evmos is a layer 1 blockchain that basically combines the best of both worlds of the EVM and Cosmos. So the EVM allowing for composability, allowing for programmability, it basically helps to ensure an agnostic way of building out and writing out applications and getting them to interact with each other. Cosmos allowing you to have sovereignty, so like sovereign chains, governance processes, etc. Most, if not majority of chains on Cosmos are on the proof of stake consensus mechanism, and that basically helps with the scalability and the interoperability of layer 1 blockchains on Cosmos. 네, I'm gonna like fill in some stuff with Korean as well, so bear with me. 에브모스는 EVM이랑 코스모스의 합친 조합이에요. EVM은 그 programmability, smart contract execution 이렇게 그런 힘도 있고, 코스모스는 약간 it's like sovereign chains, sovereignty가 있으니까 one chain마다 그런 functionality 다 이렇게 있는 힘이 있는 그런 이코시스템이잖아요. 그래서 그거를 합치면 아주 powerful한 조합이 되겠죠. 그게 에브모스의 비전이고, 그리고 EVM extension으로 그거를 비전을 좀 더 크게 보는 거예요. Cool. Oh, shoot, sorry. Okay, so basically how this all ties together with EVM extensions is that EVM extensions bring a lot more optimization to these worlds and allow both worlds to tap into each other's ecosystems by leveraging the interoperability of Cosmos and the programmability of the EVM. That was a lot of buzzwords and a lot of hot and fancy words in that one sentence, so let's try to break it down together. But first, let's actually understand the problems that we're tackling in the first place with EVM extensions. So the first problem is onboarding end users is really, really hard. Like if you think about it, with every chain comes with its own token, its own features, its own functionalities, its own like different on-ramps, etc. So for those who are not crypto native, like even myself, just like not too long ago, it's actually really hard to know where to even start, like where to even like look at, what to even learn. And once you even get started, like if you're on a chain and you start getting onboarded onto the different features, functionalities, the different apps on it, it's not like you can actually transfer that knowledge very easily to a different chain. So you'd have to onboard again separately. Like I'm pretty sure when you started getting into it, like you know this pain, I definitely know this pain. It's super unscalable, and it's one of the bigger problems that exists within the Web3 world relative to Web2. So what we see at Evmos is we see a world where you just need to onboard once, and you don't need to keep onboarding separately, and you onboard once and then still get to interact with the other dApps, with any kind of apps, irrespective of which chain you even started from. So we want to tell our users like, hey, come to Evmos, get started here, have access to everything in the Cosmos ecosystem in one single seamless user journey without really leaving where you started or even leaving where you're really the most familiar with. Cool. So the second problem is currently a lot of applications are cross-chain, like they're not multi-chain. So previously I just talked about how end users need to onboard separately multiple times, but now you as developers, imagine you having to deploy your application like multiple times to multiple chains. It's not just like, it doesn't end after deploying to one chain. You have to deploy your application to all the other different chains out there in order for you to also get more users using it. So like, this not only puts more work on you, and like it puts a lot of work and overhead on your deployment, but it also prevents your ease of access to more users and communities in a very scalable way. So I mean, isn't it like the more sensible thing to literally just deploy once and forget about it and know that like all users have access to your application after just that one deployment? Like it just makes so much more sense. There's no overhead for you. And honestly, why are you building something for so many users when the deployment stuff is preventing you from actually scalably reaching your end users in a scalable way? So how can EVM extensions help? With EVM extensions, we basically want to enable our dApps to be scalable and be powered by the interoperability that already exists in Cosmos. Now remember, the whole spiel here is that we want to leverage the fact that Evmos combines the best of both worlds of the EVM and Cosmos. We've already established that. Without these EVM extensions, you already understand that EVM smart contracts are only confined and restricted to the logic of the Ethereum virtual machine. yes, smart contracts can talk to other smart contracts on the EVM or even on FMOS, but they're limited to the logic inside the EVM, and they don't have access to any kinds of information, additional data, or even features or functionalities outside of the EVM. So what we see with these EVM extensions is that now these smart contracts can access further core functionality on the Cosmos protocol, such as voting, staking, and now even access to IBC. That allows you to then communicate to other IBC-enabled chains. This is like a very big game changer because this was obviously not possible before. So what we're basically allowing is we're allowing smart contracts on the EVM to directly call the underlying protocol of the Cosmos SDK, while allowing users and developers alike to basically just like stay where you're the most familiar with in Ethereum. So now to kind of clean it up with EVM extensions, now smart contracts can talk to other IBC-enabled chains, and at some point we're also planning for smart contracts to talk to other smart contracts on non-EVM chains. Cool. If I want to like sum this up in Korean a little bit, please bear with me. So 문제들을 두 개 제가 방금 얘기했잖아요. 한 개는 end user. end user가 이렇게 크립토에 별로 모르는 사람의 그 체인에 대해서 배우고 싶으면 한 개 배운다고 10개를 배우는 게 아니잖아요. 한 개 배우면 또 다시 다른 거 배우고 또 다시 다른 거 배우고 이렇게 되면 시간 낭비가 너무 나잖아요. 그래서 그 onboarding을 조금 더 쉽게 우리가 하고 싶어서 이런 EVM extension을 만들었어요. 네. 그리고 똑같지만 좀 비슷한 문제가 그 developer도 애플리케이션을 deploy 할 때 한 군데에서 하면 just one chain deployment. 근데 multiple chain deployment 하면 한 방에 one chain에 deploy 하는 것보다 10개 할 수 있잖아요. 그러면 유저들도 더 그 reach가 되고 커뮤니티도 reach가 되고 피드백도 올 수 있고 그런 거를 그렇게 like we're trying to make it scalable. We're trying to make it as efficient as possible for both parties, for developers and end users. It's kind of funny that I'm kind of mixing this in both Korean and English, but yeah. Cool. So, okay, I basically went over more of the conceptual part of the presentation. You probably want to understand like how can I actually apply this in an actual use case. So let me talk about the staking index use case. So essentially, you can optimize staking with these EVM extensions with, for example, indexers. Maybe you can set up indexers that automatically redelegate your tokens according to your preferences and your criteria. Like for example, maybe you care about validators who are spread across multiple different regions, or maybe one of your criteria is you really, really are conscious about how validators are practicing certain eco-friendly practices, what have you. It's really up to you. Another use case here is you could have staking managers manage your staking position, or you can even run and deploy liquid staking derivatives by accessing the staking functionality that we already provide in our EVM extension modules for staking, which I will actually show you before the end of the presentation. Cool. So I know we're at ETH Seoul, but also I know a lot of you are interested in IBC-enabled use cases. So this is a really exciting one. It's liquid staking outposts. So if you don't know, Stride is a liquid staking zone. It basically allows users to send FMOs to Stride, and the user can do a liquid staking transaction and receive the liquid stake tokens back, and then you would do what you want with it. But as you can imagine, this takes a lot of different multiple steps. So again, for someone who's not as crypto native or someone who's not as patient with all these different steps, it's not really like a pleasant experience. So now what the user can do is with EVM extensions is you stay on the FMOS mainnet, you send an EVM transaction to a smart contract to basically tell the smart contract, like, hey, perform an IBC transfer. Because once Stride receives this, or they have a logic where when they receive an IBC transfer, they know that they have to liquid stake tokens, and then they return it back. So essentially, this is an outpost. It's like when you're interacting with a smart contract on FMOS. So from an end user perspective, as you can imagine, like this actually all happens in the background. Everything that the only thing that the end user is doing is they're submitting an EVM transaction and they're getting an output. To be honest, that's honestly like one of the better UX principles of Web 2 relative to Web 3. We really don't need to make the end users care about anything that happens really under the hood. So with this use case, we actually enable a much better seamless user experience for our end users, and US developers are actually able to implement that. Another really exciting use case is DEX outposts. So essentially, the idea here is that smart contracts can also use EVM transactions to swap tokens and even provide liquidity, one of our favorite words in this industry, right? So the idea here is that anyone can send an EVM token to an Osmosis outpost, because that's one of the teams that we're working with here. And then with a memo and instruction that says, hey, can you swap my FMOs for Osmo and return them back? And this would actually really depend on the functionality that Osmosis even provides, but that's the idea that we're kind of running with here. So essentially, the reason why I wanted to bring up this use case is that, yes, we want to bring more optimization with EVM extensions, with core Cosmos functionality, but we also want to enrich the DeFi ecosystem on Evmos. Yeah, like we already know that Evmos allows developers, to tap into interoperability, smart contracts, programmability, composability, all of the bigger words. But also what's really important is that we also want to make sure that liquidity is not fragmented, like it's not siloed to just one chain. We all know about TVL, it's total value locked. And if you think about it, by definition, that means the total number of tokens that's locked into a single chain. There's an inaccuracy behind that statement because liquidity is actually spread throughout the whole ecosystem, across different chains, across different apps. So what we want to do with EVM extensions is that we want to redefine that whole concept of TVL and basically allow dApps to access all this liquidity across all these different apps so that we provide more scalability to our developers. So if you want to take anything out of what I just said here, honestly, the whole thing here is that with EVM extensions, we want to provide, yes, the optimization to the functionalities that we already have, power that with the interoperability of Cosmos, and make dApps a lot more scalable and also accessible to more end users and make it a lot more efficient and easier to develop by developers. Also, I don't know if you've had any confusion, because I did when I was learning about this, but the difference between an outpost and an EVM extension is that an EVM extension is at its very core, low-level infra, whereas an outpost is more of like a direct use case that other chains can use to provide those functionalities for their users. Cool. So this is also another exciting project that we're also looking into. So right now, I just talked about onboarding and usability and making sure that all of our end users and developers are able to onboard quickly, able to use Evmos better, and develop dApps a lot more in a scalable way. But once we tackle those issues concerning onboarding and usability, we also want to provide a solution to discoverability. So with the dApp store. This is a platform that we're also thinking about, creating a marketplace where end users have the ability to search for different dApps that they might encounter during their user journey, and also provide that platform the exposure to the developers providing or developing these apps for these end users. So it's essentially a marketplace if you think about it. Of course, there's going to be a revenue-based model for developers. Those details are soon to be hashed, but this is a really exciting thing that we're also thinking about and looking into for the coming future. Cool. So I don't have a live demo, but I do want to walk through the very specific steps that you would take to create a smart contract based on one of our EVM extension modules that we already have online. So everything else was more of the theoretical and conceptual part of the presentation. Kind of want to walk you through these steps just so that you can see how easy it is. And also bear with me, my engineering team is still in Berlin right now, or rather in Prague. So they're not here, but if you have any specific technical questions, let's talk after, and then let's see how we can figure it out together. And if not, I can always toss the question to my team, and they'll get back to you promptly, and I can even connect you with the team. Cool. So what we're going to do is we're going to deploy a contract called the simple stake. You'll see online in our documents that our core engineering team already provided this very simple smart contract online for you so that you can try it out and see how easy it is to run a smart contract using this staking EVM extension. So with this module that we're about to see, we're going to be able to stake tokens and personalize that experience. So for example, you want to stake with your favorite validator, or maybe you want to withdraw staking rewards directly from our dashboard. And the steps that we have to take are very simple. First one would be we need to approve. Then we need to compile a contract. Then we'd have to connect to testnet, of course, fund the accounts with some TEVMOS, deploy the contract, and just interact with it. It's really that simple. Even I can do it, and I'm not even a developer. So with approvals, here, this works if you want a smart contract to basically manage your funds for you or stake your tokens according to whatever preferences that you have here. Of course, these authorizations and these approvals are very necessary because you want to authorize a smart contract to do this for you on your behalf. And there's also like specific functions that basically approves the following like methods like staking rewards and also withdrawing staking rewards. Or sorry, staking tokens, sorry, and withdrawing staking rewards. Then after, it's just a matter of just going for the next steps. You'd have to compile the contract on Remix. Then you have to connect to testnet, so testnet FMOS. You have to fund yourself, fund your account with TEVMOS. Of course, you can do this with Faucet, as I'm sure you know. There's also different methods as well. Then you just deploy the contract after putting in a few configurations. And then you'll see that there's contract information coming up about your transaction hash that you can also monitor in the MetaMask extension or even on Block Explorer. It's all pretty like self-explanatory information there. And then upon successful deployment execution, you'll see all the methods that were part of the contract. And then after, it's literally just a matter of interacting with your contract based on whatever use case that you want to fulfill for yourself. You could stake some tokens, you could get a list of validators, you could stake your tokens with validators with specific preferences. It's really up to you. And that's the whole beauty of these EVM extensions, right? A lot more personalization and also in a more scalable way. These are also the list of EVM extensions that you'll see in our module online. I actually should provide like a QR code. I completely forgot about that. And I know I just talked about the staking module, but also there's an IBC transfer module. So there's the different transactions that you can perform. And as you know, every transaction, there's an event, and one of them is IBC transfer. Cool, so that's basically it for my presentation. I basically just wanted to make an emphasis of like how exciting EVM extensions are for our team right now. We're really tapping into fixing a lot of critical issues that exist in the Web3 space for not just developers and for not just end user, but for both parties, right? Making it scalable and making it really easy to onboard to as many chains as possible without the overhead of like not having that ability to knowledge transfer. Cool, so I'll be here throughout the whole day. Please feel free to reach out to me. And yeah, thank you for your time.
All right, next up we have The Graph. They'll be doing a talk on full stack Web3 development with The Graph.
Hello. Okay, guys, close your eyes. I don't want to show you this. Are we good? Okay. First of all, really, thankful to be in Korea, exploring the neighbor maps and being lost all the time. Anyways, a big shout out to Krishna, who is also from the Graph and has given me this laptop to present. I'll be talking a little bit about how the Graph or what the Graph does. And at the end, if you follow this particular documentation or my particular live demo, you should be able to code your own first subgraph. It's very easy. We'll be doing it in 30 minutes. So if you are a developer or somebody who wants to develop a particular subgraph, in 30 or just 5-10 minutes, just get your laptops and let's do something great. What does the graph do? It's a pretty heavy term. Indexing. It indexes blockchain data. But what is indexing, right? Indexing is something what Google does to Web2, right? Basically, you have all the web data that exists on the internet, right? For example, if I want to search ETH Seoul, right? There are so many things in Seoul that are happening. There is this fried chicken, then there is this soju, then there is so many things. But when you search ETH Seoul, why does ETH Seoul come all the time? And the reason behind that is that the graph has indexed the Google has indexed everything according to what's required. So whenever you query Google, it gives you the right Web2 data. And that is the reason why web is so much accessible. If we did not have Google and the indexing power of Google, you could not actually access the web. It's similar to if you have a 10,000 page book and you want to find a particular page which has your particular context. And the index page gives you that. So the graph is like the index page of Web3. The Google is like the index page of Web2. So the graph indexes blockchain data, just like the Google indexes Web2 data. On the internet, there is so many things. It's not open source. That's why for Google, it's a little tough to index Web2 data. But blockchains are open source, right? All the data that exists is live on the blockchain. Anybody who needs data just can run a particular graph node and get all the information. So that's why in Web3, indexing blockchain or indexing information becomes even more interesting. And that's why we have the graph. So basically, why do you need indexing? So if you go on top with this particular GIF, you can check that the things you have is the block data. And at the end, what you get is what you want. Basically, what I mean is that in a particular block, there are so many data that exist. For example, you just want the Uniswap data, right? You want to know that USDC, USDT swap was the rate for that, or how many people are doing a USDC, USDT swap in one particular second, right? You just want to get that particular information. But in a particular block in the blockchain, there must be information that you want, or that there must be information you don't want. In every third block on Ethereum, Uniswap puts a particular transaction, right? And you want that transaction for your Uniswap data, but you cannot, you cannot just discard all the rest of the data. A particular block has so many information, but you just want your information. What the graph does is separate the information and just gives you the Uniswap information that you require, right? You can do it in other ways too. You can basically run a iterator on every block in the blockchain, get your information, put it on you, but that would take a long time. So if I go to info.uniswap page today with this particular method, I will access it today, and I will get this information in next ETH Seoul, which is in June 2024. How do you make it quick? That is via the graph. The graph is a middleware in between your smart contract and your front end, so that you can index your information, which is your smart contract event information, and put it on your UI. If I take an example, if I go to, for example, this thing called info.uniswap, right? This, most of you who have traded or have understood Web3 must have gone to this particular website. All the data that comes on this particular dashboard of Uniswap is powered by the graph. Uniswap has smart contracts. Uniswap has a front end. But how does this particular data populate into the Uniswap front end? That is via the graph. And if you don't believe me, which you should, you can also check it here. I just can type, and I will be able to get the graph data. Just expanding on this header, if you check, this is, can I not expand this further? If you see this particular API, this is the graph Uniswap API. So what the Uniswap team did to index their smart contract needs is that they created a subgraph for Uniswap smart contracts so that they could portray their information on the front end. And you can either use the already created subgraphs for your own needs. Let's say you want to create something like crypto fee info, which is a great website, crypto fee info. Right? These people don't have most of their contracts, right? They don't have their own subgraphs. They use, let's say, Uniswap subgraphs for this particular information. And this is such an important information. They have not created their own subgraphs, but they have used the already created Uniswap subgraphs for this particular information. But if you're building a dApp and you have your own smart contracts, then you can build your own subgraphs. And this is what we are going to do today. So let's stop talking and let's start coding, okay? If for somebody who does not know the graph, they would have to install Graph CLI. So if you have a laptop and you have the urge to code, let's just please follow me. This is, let me just go to the graph.com/studio. Is this visible, guys? I hope it is. You then go to create a subgraph. No, wait. Let me just go to create a subgraph and name it Krishna, who's right here. And I'll be deploying it on Sepolia because nowadays even Gorley is expensive. Create a subgraph. So our subgraph is created. No, I'm just kidding. This is just the dashboard to create a subgraph, right? And first of all, what I'll do is install the Graph CLI, which exists over here. So this is the information you need, right, for the graph tooling. This is not the start of our workshop. This is just the information you need, the libraries and the packages you need before you start using the graph. Once you have this, the most important thing is let's create a smart contract first. I go on Remix. I am on Remix. I hope everybody has used this. If you have not, then you should use it in this particular hackathon. And I will create a new workspace. And let's deploy ERC20's token, do an ICO, get $1 million, and just get out. Anyways, so I have created an ERC20 smart contract. This is a simple, basic, vanilla ERC20 smart contract which is mintable. And what I do of this particular smart contract is I will deploy it on Sepolia. I have this smart contract, very, very simple. Let's just deploy it. Oh, there's an error. Fine, it deploys. Let's just deploy the smart contract. Up till here, I don't think there is anything new that you guys might be seeing. No. I have to shake it to MetaMask. Let's deploy the smart contract, confirm the transaction. And so I have my ERC20 token smart contract deployed. Hi, Sam. Hey, how are you? Not good. Very good, very good. Sorry. So I have this smart contract, right, which is the ERC20 token smart contract, and I have named it my token, right? This is a smart contract, and it is already verified on Etherscan. If you create your own custom smart contract, you'll have to verify yourself. So this is a smart contract, which is the ERC20 token, right? And right now, it does not have any transactions. What I'm going to do now is the graph part. As of now, we have deployed a ERC20 token, right? That's all that we have done. And we have installed the Graph CLI packages. Now, I just go here, just close these things. No, not this one. Yeah, I'm in the terminal. You might not be able to see it. Can I increase? Is it visible? This is the place where magic happens, right? Okay, I'll create a ETH Seoul. I'll create a folder for myself. Go inside that particular folder, right? Now, I will just do a command and my subgraph will be created just by a generative tool, that is the graph CLI. So I do graph in it dash dash index events dash dash from contract I go to the place where my smart contract is, not this one. It's the other one. Yeah. Here is the smart contract address. I take that smart contract address and I just paste it over here. And I'll have a subgraph which will be indexing all the activities that I do on that particular smart contract. Let's do Ethereum. Let's do it on the Graph Studio. Let's name it Krishna. I'll deploy it on Sepolia. Yeah. This is the smart contract. It is being able to fetch the start block. The start block is not this one, man. Okay. The start block we'll have to find out is this one. And it's installing the dependencies so that my ERC20 subgraph is created. What I've done is deployed a smart contract, right? And now I want to track all the activities that I do with that ERC20 smart contract. Let's say I mint a token. I transfer the token. All these things will be tracked via the subgraph, and that's we'll see right now how did it happen. No. Okay, our smart contract is here. Our subgraph is also here. Okay, so we have our subgraph deployed over here. Let me just go a little detail to explain you what does this contain. So this one has, first of all, your smart contract address. Secondly, it has the start block. And third, it has all the events that are in your smart contract, which includes approve, transfer, all these things, right? When you create a smart contract, you always define events in it. These are the events which are listed over here, right? And these are the event listeners that exist. So this is the YAML file, which introduces your subgraph to the graph node that, hey, this is my smart contract address. These are the entities you have to index. Just do it. Secondly, what you do is define the schema, right? You define what you want to see. If you're deploying a Uniswap subgraph, you would define, let's say, a swap, right? And in that swap, you will define the token name, the amount, all these things. When I'm deploying a ERC20 token, there are like a few events that happen inside. Let's say approve, ownership transfer, transfer. All these entities are predefined, but they are as per generated code. If you want your own entities, you will have to just change this particular schema according to your needs. The third thing, and the most important one, is the mapping file. This has all the code. So basically, what GraphNode does is that it sees the event, it gives you all the raw data. This mapping file converts that raw data into schema file. Let's do it again. I know I'm a little, fast. So basically, what we need to do is that GraphNode indexes all the event data and gives you the raw data. But you don't need the raw data. You need the schema data, right? So the mapping file converts the raw event data into the schema data. So basically, all the event logic, all the data and logic resides inside this particular mapping file. And that's all that you need to code to create a subgraph. We have everything. We have a smart contract deployed. We have our subgraph created. Now let's deploy it. And I'm going to show you how easy is it to do it. This is my studio. First of all, hopefully you have installed the dependencies, and I've done the init. The next thing is I do the graph auth. This is just something that's required to just deploy on your place. Okay, graph auth done. Then I will do a code gen and a build. And again, I'm just copying things from the dashboard. And I'll deploy the subgraph. 0.0.1 version. Okay, we have our subgraph live over here. This is the ERC20 token, and this is our subgraph, which is indexing all the data. Right now, what data do we have? Nothing, right? We have not done. Oh, we have something. What? Okay, let's check a transfer. We never did a transfer. Let's check a transfer. Transfer. Transfers. First 10. See, I am legit, right? We don't have any transfers. Now what we will do is mint a token. Let's mint a token. Mint. I'm going to mint it on myself, right? Because it's an ICO, remember? The foundation gets 100% allocation. I'm just kidding. Mint to this address. Let's do 100. Transfer. Confirm. And you can see, once the confirmation happens, I will get some information in my transfer. Etherscan is still indexing the data, but the graph has already not indexed the data. It happens, guys, it happens. We'll blame it on the internet. Erica, see, woo! So, demos should be fun, right? They should not be, oh, guys, this is my project. So this is how you create a subgraph and index all the information from your smart contract. And good news for you guys is that I'm in Seoul, so you can run about subgraphs, do some hackathon stuff. And at the end, my treat is a soju. That's all I want in Korea, of course. So if you have learned something from this particular demo, do tweet about it. This is how you scan. Let's create some noise that you deployed your first subgraph. Let everybody know that subgraphs are awesome. The graph is awesome. And Seoul is awesome. Soju is awesome. Fried chicken is awesome. Erica, who has created this crypto soul thing, is awesome. Big shout out. Yeah. Why do you need subgraphs? Because there is about 15 million blocks that exist on Ethereum. And if you scan every particular block and get every particular transaction in that particular blockchain, you will be paying more money to Google than it's required to buy the whole Google, right? That's why you need something like the graph so that it can index transaction data and give you all the results. You either create your own subgraph if you are deploying a smart contract, or you can use already existing subgraph for amazing dashboards. We are sponsoring this hackathon for all the amazing hackers. So if you're creating a new subgraph, we have $1,800, which is awesome. Or if you are using an existing one, we have $1,500 as grand prizes. And me and Krishna, as we were saying, will be here all 2 days. So if you are writing a smart contract and deploying smart subgraphs, then reach out to us. We'll easily be able to help you out. As I told you, it's a very easy step. Deploy a smart contract, do graph init, have the index data, create a schema, use that schema for your front end. That's it. Thank you. Do we have time for questions? Okay, any questions? I'm a very good presenter. Normally there are no questions. Okay, cool, thank you.
All right, next up, we have Sam from Node Guardians. He'll be doing a talk on making learning assembly as fun as playing Diablo 3.
Oh, hello guys. 안녕하세요. I'm a bit embarrassed. I have this Mac that do not have the HDMI system. So does anyone by any chance has this little adapter that converts USB-C to HDMI? Otherwise, maybe we can just like load my pitch that's in the Google Drive and put it on the screen. We have the laptop. The laptop can what do you mean? Oh yeah, yeah. Oh yeah. If it could load my presentation, that would be more than enough, I think. Okay. Can I send you on Telegram?
Yeah, yeah.
All right. Just 1 minute. Okay.
This presentation is also sponsored by the Graph.
I'm testing it right now. I'm sending you this. Can I use your ETH? The MetaMask is
ETH?
unlocked?
Yeah, okay.
Okay, the girl.
But Sepolia.
Okay, all right, Sepolia. So you should have it now.
I don't have like ETH, normal ETH.
So, oh, thank you. You're my savior.
Oh.
I just developed the subgraph for you.
Oh, wow. You have it.
Fantastic.
Yeah.
Okay. Do you get the signal? Oh, fantastic. So I'm gonna put this in diaporama mode or slideshow. Okay, chargement. Should be good. All right. Okay, so thank you for your patience. I guess I should speak closer to the microphone. I'll start with a quick question here. How many of you guys are programmers? Okay, so quite a few. And how many among you are familiar with Solidity or Cairo, or Rust? Great. Okay, nice. So very quickly, I'm Sam. I've been passionate about cryptography and more importantly, it's concrete use cases for the better part of the last 6 years. And I'm very excited to talk a little bit about Node Guardians. But first, just some background about me. I'm the founder of Node Guardians, and it's been a fun ride. I've very weird background. You know, I've had these parents which I was basically in med school. I dropped in the middle, and anyway, I had the choice between like the law school, the engineering path, and the doctor path. So I basically just dropped everything and played Age of Empires 2 at a high elo, and started reading about blockchain. So out of this, I was basically like venturing and trying to see what could I do to contribute to that space, build a few initiatives. One of them is Journal du Coin. It's like a French media that deals with blockchain. It grew to a few million users a year. I did some podcasts, learned a few things, and also we've done some stuff that maybe we shouldn't have done. That's pretty much it. So a very weird path. And then what I was trying to basically develop Journal du Coin, I was working with a lot of the leading foundations. Edge and Node is one of them, Pranav, but also other Ethereum-centric, let's say, foundations. And I discovered a major problem is that they were facing a problem where basically creating and maintaining high-quality resources for experienced developers to basically engage and get new developers was really complicated. Either like the resources were not free, or they were like scattered, or you had to do some weird stuff to access the chapter 2 of the resource, like giving your Twitter or retweet something. And yeah, it was definitely not easy. So I asked myself, what could be the best way to, yeah, to create an experience for me to experience, senior developers to level up their knowledge in the most fun, community-based, and permissionless way. So that's how I came to build Node Guardians with my amazing team, which is unfortunately not here, mostly in France, but I give them a great shout out because they're doing some amazing work. So that's pretty much it. Node Guardians is a role-playing game that caters to seasoned Solidity developers. It's very, very simple. You log in with your Web3 wallet, and you have to solve lore-based programming challenges, a little bit like in Heroes of Might and Magic, or Baldur's Gate, or Lineage. Each quest has a narrative arc, and based on the code that you ship, you basically unlock the ending of the quest. So I said it caters to seasoned Solidity programmers. Maybe in the future we'll expand it also to beginners, but the idea is just to create an experience that's reminiscent of role-playing games, while actually tackling like complex Solidity problems like advanced design patterns, good practices, etc., etc. So I'll go for a quick demo at the end, but I'm just showing some quick screenshots here. That's it. And while you complete the challenges, you unlock some soulbound rewards in the form of gold and XP that you cannot trade, and you can use that to craft some of the hundreds of in-game items that we've built that represent how proficient you are as a smart contract programmer. And again, for the whole experience, you do not need to give me your email, your name, or your phone number whatsoever. You just take a burner wallet, and you can get started. We also have a ranking system, a leaderboard, where based on like your level of completion of the game and soon how gas efficient your code is, you can climb up the ladder, a little bit like, like the StarCraft Elo, the League of Legends Elo. That's the same thing. And yeah, one question that a lot of folks among the crowd might be asking themselves is, why would I even solve these challenges? Because just knowledge it's probably not enough. So we have a whole progression system. You start as a scholar, then you become a mage or a high mage, and eventually a guardian. But that does not imply any obligation. You don't need to give me something or some money or your like your phone number whatsoever. You can just like go deep down the game, complete challenges, and unlock access to these different status. What it enables you is access to different like IRL events that we organize, CTFs, and different like meetings that we do all around the world, in France, in Portugal, in the US. And one cool example, for instance, is that if you're a developer looking to contribute to meaningful open source projects or to build some things and get close to some interesting foundations, for instance, we tend now to organize some kind of hacker houses in different cities around the world. The one that I'm announcing now is that one in Paris. You can stay for 1 week in Paris, in the center of Paris, and hack with other like, open source contributors, hackers, and DevRel from Starknet, but also beyond, on very interesting problems. And as a guardian, you don't need to pay for your accommodation. So we try to select among the first ones that manifest their interest to join us, and they can just get some fun experience and be part of that community. And there's more to come. So yeah, we have some folks from our community contributing to cool initiatives like the Kakarot ZK EVM or the Madara sequencer for Starknet app chains, but also a few others that I can introduce later. And the idea is that based on how high your profile is on Node Guardians, you can use this proof of skills to be match-maked with different foundations and protocols and eventually land a job or work as a contributor on something that's compelling to you. If you want to keep your main job and you just want to do some contributions on the side, this is actually possible. Right now, you just need to reach out to me on Discord and we can figure out a way to match-make you with someone, and it's really seamless and based out of consent. I'm not going to send you an email whatsoever. I really insist on that aspect. And soon, very soon, probably next month, you'll have a matchmaking interface where you can just like select whatever is relevant to you, and then you take it from there, and you get to work with the project that's relevant to you. So yeah, that's one of the interface, basically like the interface when you want to share your profile. There's some kind of skill tree that represents how far you've been like in design patterns, low-level programming, etc. And you can also like display your armor. Some items are really hard to craft, and some items require you to complete some specific CTF in a given time frame. So that's pretty much it. It's a public good, and it will remain like that. So it's not a pay-to-win whatsoever. It's free to play. And yeah, some cool metrics that I could share with you. We have about 80 hours of content on Solidity that's available right now. Yeah, 670 developers actually pushing code through the pipeline. So that's actually active users, not like, yeah, people just signing up with MetaMask. And yeah, there are 4,320 quests that have been completed, programming challenges. We are yeah, fortunate to collaborate with different ecosystems that ship interesting technology, like yeah, Axelar, Starknet, Celestia, and some others. And right now, we're working towards our next big integration, which is supporting Cairo 1.0 Node Guardians. And yeah, when we mean integration, it's like a DLC on World of Warcraft, like the Burning Crusade. It's dozens of hours of content, a new lore, new armors, new collectibles, and a total, like a new intrigue for the challenges and new mechanisms for these CTFs, some new spice. So every character in Node Guardians and every quest, like they're kind of linked. There's one quest that matches with another, and there are a lot of Easter eggs that are hidden, and there's sometimes some rewards to spot these Easter eggs, let's put it this way. So yeah, we're really trying to provide an experience that's reminiscent to people who love role-playing games or just gaming in general. But if you hate gaming, it's totally okay. I respect that. We've designed the product in a way where you can skip the lore and just focus directly on the technical problem and just hack your way through. That's it. That's totally okay. Regarding the types of quests, I'll introduce them very quick, do a quick demo afterwards. We have the build challenges, where you need to solve an arbitrary programming problem. But for these ones, you need to fork a public repository on GitHub and install our GitHub so that we can run private tests to see if your code satisfies certain criteria. Then you have the pure CTF, like steal the money, manipulate that oracle, whatsoever. Everything is done on testnet. You don't need anything to do that. No credentials on GitHub whatsoever. What I call resource management or gas optimization. And then you have theory. Theory, these are actually articles that abstract the complexity of some, you know, like concepts like elliptic curve cryptography or zero knowledge or, yeah, what is like randomness. Stuff that you might need to know before tackling some hardcore like practical problems. And that can actually be fun for someone who's not a developer in the crowd. You can just check these quests, read them, and yeah, potentially learn something out of that. So that's pretty much it. And as the name suggested, and there's a lore around that, we are node guardians. So we guard the nodes, and yeah, you can consider delegating on our infrastructure, contributing whatsoever, you're more than welcome, but that's not an obligation. Yeah, we also have a team of 11 passionate developers and product specialists. We're soon going to scale, so if you wanna join us on this fun trip, fun journey, keep an eye out on our Discord. And the idea is that you don't need to join us formally as a team member to contribute. We're slowly moving towards a fully permissionless protocol, and we have different contributors from you know, the Ethereum Foundation, ImmuneFi, and different you know, like different entities that are either pushing theory or practical content. So progressively, the ownership of the platform becomes the guardians, the actual community members. What's next? Probably planning to pivot to AI. I still haven't made the decision, but actually, if you want to discuss about like around this, I'm more than happy to talk. Can't really reveal that on stage. That's it. The platform is www.nodeguardians.io. You can find it there. If you have any question about Node Guardians, I check all my DMs on Twitter or on Discord. If you have any issue with a challenge, every engineer at Node Guardians is actually a community manager. So we'll be more than happy to give you the right amount of hints so you can untangle your situation with one of our quests. And yeah, that's pretty much it. Thank you so much for for your time, and I propose that I just show you very quickly how the interface is, how it looks like, what's the flow, and then I'll be more than happy to answer any questions that you might have. So, yeah. So I logged in here with Rabbi or MetaMask, whatever floats your boat. I have my profile. That's it. Don't need anything else. I have like the skill tree that I told you about, the quests, and you can see like the different, like the different topics that we explore, the type of quest, and the XP that's at stake for each quest. And then you have campaigns, a little bit like in Age of Empires or any other game. Campaigns are, there's a story that unfolds. You have different chapters, and yeah, there's an intrigue that develops as you go further down the campaign, and all the quests within a campaign gravitate around one same topic. So feel free to check them out. This is, for instance, our Rect CTF. So I don't know if you know the Rect leaderboard, but there are a lot of notorious hacks out there, and we just took some of the coolest out of them. That's a bit weird to say that. And we created some situations on the testnet and some contracts that look exactly like these exploits before they happen. And the idea here is that you leverage the same patterns to break these contracts, and you kind of learn the right security anti-patterns to ship production-level code and avoid making mistakes that could lead to potential millions of dollars being lost. So yeah, we have different challenges like that. We always try to give you some inputs, some stuff that you might need before like solving the actual problem. And then you have the contract. You can deploy the trading boat on Gurley, and that's it. We just give you the right amount of Gurley ETH so that you can deploy the quest. And if you complete the quest, you get, again, some more Gurley ETH to deploy another challenge on the testnet. So that's pretty much the flow. We have like a wide range of topics that are explored, and we're looking to support other stacks in the future. And yeah, that's the fun part here. Once you complete the challenge, you can actually go to the forge, scrap, mix different soulbound items, and create this proof of skills in the form of like, armor, swords, items. And yeah, there you can monitor also your progress, your ranking, and yeah, the amount of quests that you have completed in the past. That's pretty much it. Forgot to say that we support different testing environments. So Foundry is supported, Hard Hat is supported, and yeah, I really hope to see some folks among the crowd on like trying out Node Guardians, trying out the CTFs. That'd be really cool, and I'm happy to answer any question that you might have.
All right, next up we have Sarah from Protocol Labs. She'll be doing a talk on FVM, the new possibilities on Filecoin.
Hello. Hi everyone. Hi. 여러분 안녕하세요. 저는 세라입니다. That's about it. That's all the Korean I know, and I'll be presenting in English. But it's really nice to meet all of you. Sorry I don't have like Korean subtitles for my presentation, but I hope that it's still good for everyone today. Cool. So I'll be talking about new possibilities on Filecoin. I'll cover some technology that some of you might be familiar with, things like IPFS, Filecoin that has been around for a while. And then I will cover the Filecoin virtual machine, which is something we just launched 2 months ago. So a little bit about me. Nice to meet all of you. I am Sarah. I'm a developer advocate for the Filecoin virtual machine team. So we are very focused on enabling applications to be built on the storage on the Filecoin network. We're currently in the midst of building a lot of different tutorials, new features, new documentation that has come up in the past week or so. So really in the middle of it, and we will be present at a lot of different hackathons, as some of you might have already participated in. So cool, let's get into it. Okay, how many of you have used, just a show of hands, how many of you have used Filecoin before? Okay, how many of you have used IPFS before? Awesome. Okay, yeah, I know. IPFS is awesome. I love it. And how many of you have used the Filecoin virtual machine before? Okay, not bad. For 2 months, 1 month each. Great. Okay, so today I'll kind of cover the things that I know it's a 2-day hackathon, and we have a lot of recordings online that go deep into it. I have about 25 minutes now, so I want to focus on what you can use during this hackathon and how you can get your project built today, right, in these 2 days to go ahead. So I'll talk a little bit about your different options for storage, and I'll do an introduction. You'll understand the concepts behind these 3 different buckets of technology, and then I'll do like a quick guide on what would be the best option for you to use in your hackathon project, and then introduce some quick resources that you can use straight away out of this, like starter kits, APIs, and so on. So let's make it super easy for all of you to hack. Okay, I'll start off with IPFS, and it's good to know that a lot of people here are familiar with it or have used it in some way. For those of you who are new to this, IPFS is a peer-to-peer network. IPFS and Filecoin are separate, and this is a common question that we get. So to clarify, it is separate from Filecoin. It is not a blockchain as well. It is a peer-to-peer network. The best way that I put it across to people is that it's kind of like torrenting, but it's legal. So that's what IPFS is. What you can do is you can store your data. You can use your own node, or you can use other people's node to keep your data there. So one really cool thing is about IPFS, and this is how we are different from a lot of file systems out there, is that we don't focus on where your data is stored as a location point for you to access your data. Instead, we focus on the data itself. So we provide content identifiers, content IDs for the data that you want to upload to the system. And so every single piece of data, no matter where it sits in the world, is something that you can identify just by the ID. So even if like computer A that you initially stored it on, or server A that you initially stored it on, is no longer storing your data, it could very easily, be passed on to server B, and you can still find your data over there. You wouldn't have to rely on server A like disappearing one day and you can't find your data after that. So content IDs are how we store your data, and that's how you can recognize it. One really cool thing over here is that we are in the middle of implementing a node that also sits in space. So this even proves the point that it doesn't really matter where your data sits, but we make it the easiest way for you to find your data. So if the satellite with the node in the future is like going across your location or going across Seoul, and it's faster for you to access the data from there, it could also ping off that node to get your data even faster. So we're experimenting with a lot of these things, and we're trying to bring data faster to people than it is today. So truly, truly decentralized all the way to space, and that is why it's called the interplanetary file system. So a little bit about content identifiers. I'm gonna kind of get into how it works. So what you would do first is you would obtain the content ID for your data, and then you would then put it onto the IPFS network. This can be either, again, running your own node, or you can be using other people's node. And then you can use a data hash table to find the CID that pertains to your data. when data is stored on IPFS, it is actually broken up into a Merkle tree DAG. So that's immutable. So if you change any part of your data, the root hash of your Merkle tree DAG will actually change as well. So any data that you start, if there are changes to it, you would know based on the ID that you're trying to check it with, right? So that allows you to know like if there's any changes to your data, and it keeps your data more secure. Okay, so they kind of talked a little bit about this, about IDs itself. This is just kind of the difference between how it sits between a computer to Web2 and then to IPFS itself. And I also talked a little bit about this around how the CID works, but we won't be getting too much into it. It will actually be one of the underlying technologies for a very easy way to integrate this into your application, so I won't get too deep into this. But of course, if you want, we have documentations on this, and you can go read up more about it. Okay, and as I mentioned, so where you'll probably be using something that will relate to IPFS is around the step number 2 over here. So on top of step number 2, there are actually services today that run nodes and help to pin your content. When we pin your content, what it allows you to do is to retrieve the data really quickly. We have platforms that are built on top of it, like web3.storage, nft.storage, if you use any of those platforms. So those actually have SDKs and APIs that make it really easy for you to integrate in your application. So just to give you a sense of what it is, like what the backend is to the application that you'll be using, this is where it will sit on step number 2 over here. Okay, so that's IPFS as a whole. Now we'll get into the Filecoin, which is separate. So the difference between Filecoin and IPFS is that Filecoin is a blockchain. What we realized with IPFS is that you can store your data today, but it doesn't guarantee that your data is stored forever. So for example, if the node shuts down or they're not incentivized to keep it going, you might lose your data. So we created the Filecoin marketplace, kind of like a storage marketplace on top of that, and it incentivizes a whole decentralized network of storage providers. So we have storage providers, there are some in Korea, there are a lot in China, there are also a lot in the US that set up these hardwares on their own, or they choose how they want to store the data, and then they are incentivized through like a smart contract to store your data for you for the amount of time that you want to pay them for. And then once the deal ends, you can choose to renew it, or then your data gets dropped. But this guarantees that your data will be stored as long as you pay for it. So that's what the Filecoin network does. And we have a protocol there, and this is a layer 0 protocol. So this is the anatomy of a Filecoin storage deal. What will happen over here, and this is kind of good to know, but you don't actually have to use it in your application, in your hackathon project, but it's good to know, especially if you want to see which parts you want to focus in on or build tools or applications around. So first step will be always to do a storage deal proposal. This part is cool to know, and I'll explain it later, because when I talk about a Filecoin virtual machine, I will show you how this process gets a lot more automated with that new launch of the Filecoin virtual machine. So you will do a storage deal proposal. This will be using, this is how long I want to store my data. This is the CID of the data that I have prepared. Again, the data does not necessarily have to be pinned to IPFS, but you will have to transform it into a .car file format for it to be referred to in the deal proposal. So you would set all your parameters of how you want to store your data. You would propose it to the network over here. In step number 2, when your storage provider accepts the deal, they'll make the deal for you and put it onto the Filecoin network. And then they will continue to prove it over time, which is, we call it the proof of space-time. They will have to prove that your data exists, and your data exists the same way that it was uploaded, so it's the same piece of data. And then lastly, the deal renewal will come over here. So if the deal drops or the deal has ended, this is when you can, as a client, decide whether you want to renew your deal or not. So pretty complicated, right? We're making it a lot more easy with the Filecoin virtual machine. I'll talk about that in a bit. So over here, talking about what the steps that we have as a Filecoin network, like where are we headed? In the roadmap that we have, we're talking about scalable data storage. So we've invested a lot of time for the past 7 years building up the decentralized storage network. Now we are focused very much on data onboarding using usable and quality data onto the committed capacity that we have on the network. So we have one of the largest committed capacities right now. I think it's like 300 exabytes, but it's a huge amount of a committed capacity, and we're slowly onboarding a lot more data onto that. And then lastly, we're thinking about making data useful. So in this sense, we're talking about creating applications on top of the data that you have. And I'll address that in the Filecoin virtual machine part later on. But this is how you think of, this is useful to know like what the roadmap for Filecoin is. So as I was talking about, this is exactly where the FVM comes into it, and this is where things get exciting. So we launched this about 2 months ago, I think, 2.5, I don't know, time flies. We launched it on March 14th, which is actually Pi Day 314. We launched the Filecoin virtual machine, and what it does is to add programmability to the Filecoin network. What we foresee is that if you think about Web 2 today, you have servers, you have data, and then you are able to create applications on top of that. So we want to be able to do the same thing, and we don't want to just be a storage network. So that's why we created the Filecoin virtual machine, so that you are able to compute the metadata of the storage deals. You know, remember how we talked about the storage deal cycle earlier on? So all those storage deals that are stored on the Filecoin network have like metadata attached to them, right? When your storage is stored until, what the data is about, how large the size is, and so on. The Filecoin virtual machine is then able to compute the metadata on-chain for you. So that allows you to create applications that are storage-focused, and you can manipulate or write custom logic to how you want to store your data, how long you want that data to be stored. Do you want to send it to a decentralized computation framework to compute a result and then send it back to the smart contract, and so on. So these are all the possibilities with the Filecoin virtual machine. A little bit about this, and to focus in on where we are, this is the architecture of the Filecoin virtual machine. Some of you might have seen this before. The Filecoin virtual machine was created to be an instance that is VM agnostic, but I know all of you were at ETH Seoul today. The first virtual machine instance, the first foreign runtime that we wanted to focus on was the Ethereum foreign runtime. Of course, because the EVM community is huge, and we want to be able to provide that storage capability to the Ethereum community. So we focus very much on providing full EVM compatibility. So if you're a Solidity developer, all your different tools with like MetaMask, Foundry, Hardhat, so on, will be compatible with the FVM. You will be using the tools as you are used to. The only difference is that you're deploying to a different testnet. So eventually, you will be deploying to the Filecoin network. So you can still, use all those, and we're working on partner integrations right now, like things like Telor as an Oracle, Axela as a cross-chain bridge, all these different things that you can use and that developers are familiar with, so that you have a very rich development environment that you are able to deploy to the Filecoin network. I do get the question as well a lot on why use FVM and not EVM. So the difference here is that you are really being able to do everything in a native environment. Of course, the impact here is not so much when you're developing it, it's more so when you deploy your application and you're actually implementing it. So you'll see a lot of differences in like a significant reduction in cost, especially to do with storage. So rather than writing in the EVM contract and writing to a storage platform separately where you're paying those fees, you could use it within the same environment, and so your costs go down a lot. Performance-wise, it's also much better. I can go into a deeper analysis there, but generally performance would be much better using everything in a native environment. And so that's the main difference that you get with using the Ethereum, the EVM-compatible FVM that we have today. So as I mentioned, the really cool part, today, like before we had the FVM, people couldn't really do much with the storage. You could only store it and then retrieve it on the Filecoin network. But today, you are able to interact with the Filecoin protocol itself. So this is allowing you to go in and write like your own actors, which are the equivalent of smart contracts, on the Filecoin network. The way that we do this today, especially for Ethereum hackers, is that we have the Filecoin.solidity library. So this would be one of the tools that you can use in your projects to call the different methods that are using it in a Solidity contract, but then calling methods on the Filecoin network that you would use like usually with Filecoin. So in the, if you're used to Filecoin and you're using like Lotus, Go, and you're used to those methods on the Filecoin protocol, you can actually use it and call it from your Solidity contract as well. So things like, for example, checking the balance on my contract, checking the balance on my storage deal, checking how whether the miner has accepted my deal, how long is it being stored for. All these things you can call today from the Solidity contract itself, and not having to go into the Filecoin protocol and learn a whole new set of tools to be able to do that. So just a little bit of an example here. Yeah, we're super easy. We have some resources. We have a starter kit. You can just import that and then start using the methods yourself. So I did show you this storage deal flow earlier on. So now with FVM, the things that we are anticipating is that you will be able to write custom logic. A lot of the deal flow today, again, this is if you choose to write an application that automates the storage deal that or automates or improves the programmable storage market. There are a lot of things that you can do with FVM, and I'll talk about that in a bit. But one of the things you can do is to enhance the programmable storage market. So you could automate a lot of these things, especially to do with storage and retrievals. You could also decide if you want a certain event to then trigger off the storage to be stored automatically for your application, and a lot of cool stuff like that. So that's kind of how we see the FVM coming in and enhancing the Filecoin network. So we have a fully feature-complete JSON RPC, Ethereum JSON RPC API that we use for FEVM. So again, all the tools that you are familiar with, we have versions of it. Or if you're using MetaMask, you should be able to enter your Ethereum address, connect to our testnet, get our test fill into your OX address. So it's pretty seamless at this point, and you should be able to use the toolings that you're super familiar with. We also have things like we have a hard hat starter kit, we have a Foundry starter kit for FVM, so these are things that you can fork and use. We also have explorers today that maybe if you're a Filecoin user, you might have used the Firefox Explorer or the Glyph Explorer, but today you can actually check on your transactions via the EVM-compatible FVM as well. I would say it's almost at Etherscan parity. There's a roadmap, but we're going to get there pretty soon. So yeah, if you're looking for ideas on what you can build, one example that I think is really cool is the data DAOs over here. I think maybe I've talked to some of you at the booth about it, but the idea of a data DAO and what you can build. So these are all examples of layer 2 solutions that you can build with the FVM on the Filecoin network. One of the really cool examples, and I would say play to your strengths, play to the storage capabilities of Filecoin. Data DAOs is something where you have a DAO, and your DAO is focused on a very important data set. So for example, if it's like users' credit card data, for example, you could write a data DAO where you have maybe you are able to collect all these different users' credit card data into a single data set, and then you are able to use the FVM to write access control onto that data set, and then only allow third parties to pay for access to your credit card data, and then contribute or attribute the profits back to the user themselves. So rather than your credit card data being taken by marketing companies and you don't get control over it, you could then pull it into a data DAO using FVM, get it stored, make sure that data is continually renewed via the treasury, via like automatic renewal of the data set itself, and then have that, and then be able to earn profits directly to the user just off of that data DAO itself. There are also different use cases, like maybe decentralized science. So if you want to upload a bunch of research papers into a data DAO, send some of those information out to a computation job to train an AI model, for example, and then return it back to the DAO to get those results. These are also things that you can do. But there's a lot that you can do with data DAOs itself. So really, really cool use case over there. We're really looking out for more projects in the data DAO space. There is also this resource list over here. So if you're interested in more ideas on how you can build your startups or your projects with FVM, there's a whole bunch of ideas over here that we've written out some descriptions for. OK, so a quick recap of what we covered so far, and then I'll hit straight into the resources that you can use. We have IPFS, which is storing data on a P2P network. We have Filecoin, which is storing data on the blockchain, your storage deals on the blockchain itself. And then we have Filecoin Virtual Machine, which enables you to build applications with the storage on the Filecoin network. And then, of course, if you've seen the Corgi biscuit before, this is the name of a Corgi that likes Filecoin. So it's one of our mascots. So what to use for your hackathon? So we built this, I want to say simple, but I realize it's actually not that simple. But if you have time and you go through the flowchart, you should be able to figure out what's the recommended path for you to use. Because you might be thinking, should I use IPFS, should I use Filecoin, should I use FVM? There are so many options, which one should I use? This flowchart kind of takes you through. If let's say you want storage within your hackathon project, think about whether you want programmatic storage, which is automated, and you can write custom logic, or do you want non-programmatic storage, which is just a simple storage itself. Depending on that, and depending on the size of the data that you want to store, there are different options that you can use. So I would say the most easy for most people is simple storage, which is on the right side, non-programmatic storage. It stores any size of data. There are a lot of storage on-ramps that we have. So if you've heard of NFT.storage, Web3 storage, Filecoin data tools, these are all platforms that have done all the work that I mentioned to you earlier on in describing the whole data deal flow, putting it into a platform and then giving you a really easy API to use. So most of these will be JS libraries. You can use it and integrate it into your application. Wait, I will go through these in the next few slides before I get too deep into it. But if you're thinking of using programmatic storage, which is more automated, and you kind of want to get into the details, you want to write it yourself, think about the size of storage that you want, size of data that your solution will be storing. If it is below 4 GB, which is the recommended size for storage providers to pick up a piece of data, you might want to use something of a deal aggregation that takes small piece of data, like let's say it's like KBs or MBs, and then it pulls it together into a larger deal set itself, and then makes the deal for you. Or if you want to have a larger piece of data, like 4 GB, if it's a huge data set, you can just make the deal directly yourself, which is faster in its own way, and you get a lot more control over the process there. Oh, and also, this is a hackathon cheat sheet. If you want to go in there, it takes you through this flow, and it gives you all the links that you need for starting your application based on this flowchart. Okay, so I talked about resource number 1, which was deal aggregation for small deals. This is one really good option. It's called Lighthouse.storage. This is on the hackathon cheat sheet. You can check it out. It is a very simple aggregator to use. I was going to click into it, but I also don't have my laptop connected right now into a browser window. But if you go to Lighthouse.storage, you can visit the documentation. They have an SDK ready to go. You can import the library and start using commands to upload your data, and super easy to use. What it'll do for you on the back end is to collect all these small pieces of data, put it together, and then set up a deal on the Filecoin network for you. If you have a larger piece of data and you want to do direct deal making, we have a custom contract that is already written out for you. You can fork it and start to customize it yourself. It is called the client contract. This will all be within the GitHub repo over here for FVM deal making starter kit. This is also within the hackathon cheat sheet that I shared earlier on. And I'll share it again at the end. So you can always fork that repo and start creating your own custom client contract. Again, both the first and second option will deploy to our testnet. So even though you are using Ethereum tools, you will be deploying to the Filecoin testnet and not like an Ethereum, another chain itself. And then lastly, I think this one would be super simple. I've skipped 3 and 4 only because those are a little bit more specific. But again, they are in the cheat sheet, and you can access them if you need. But here is resource number 5, which is for simple storage. So if you just want to store like the simplest pieces of data, storage is not the main focus of your application. You can use NFT.storage or Web3.storage. They have JS libraries that you can use to include within your project. OK, cool. And wasn't able to click into my browsers, but there are a bunch of links over here. I would recommend the one on the left, which has resources to the cheat sheet as well that I shared earlier on, as well as other tutorials and documentation for the Filecoin virtual machine. Again, that is really where you can start to build your applications. And then on the right side, if you want to join our Telegram group to get connected with other folks in Seoul, you can join the link over there. Cool. Yeah. Thank you so much.
All right, next up we have Matt and MJ from Proximity. They'll be doing a talk on building decentralized front ends with the BOS.
All right, check, check. Hey, everybody. Thanks for joining the session. My name is MJ. I'm the head of product at Proximity. We are a team that is dedicated to helping DeFi applications in the Near and Aurora ecosystems. And today I'm joined by Matt, my coworker, who is our head of DevRel, and we are going to talk to you about a very exciting topic, how to build composable decentralized front ends using the blockchain operating system. So let's get started. So before, just a few words on the Near blockchain. So as you all know, that Near started in 2018 as a layer 1 blockchain. We launched our mainnet in 2020. And since then, we have really been focusing on empowering developers by providing all the tools that developers might need for building their Web3 applications. So over the years, we have built a number of tools like SDKs, CLIs, APIs, templates, and so forth, because we truly believe that developers, builders, and makers are the ones who will bring mass adoption to Web3. And finally, this year, we consolidated everything that we have built over the years into the blockchain operating system. So the ultimate goal here is to help bring over 1 billion users into Web3. So next slide, please. So what exactly is the blockchain operating system, right? So from the end user perspective, it serves as a common layer for discovering and browsing all the open web experiences. So what does that mean? So imagine if there's a website where you can go and you can browse and discover all the Web3 applications that's available out there right now, right? That will be a substantial improvement over our existing user journey. And in fact, this is no longer a dream, it's already a reality. You can actually go to near.org today, where you can discover a bunch of Web3 applications in one place. And one thing to highlight here is that the blockchain operating system is chain agnostic, so it can actually work with any blockchain. So if you go to near.org, you can actually find applications that are not just on Near, but also on other blockchains like Ethereum, Polygon, zkSync, Arbitrum, and so forth. And then from the, developer's perspective, the blockchain operating system is a tech stack for them to build fully decentralized applications. So the key word here is fully decentralized, which means that in addition to decentralizing your backend services with smart contracts, now you can also decentralize your front-end services with the blockchain operating system, which we'll dive into later in this presentation. Next slide, please. So what exactly are the problems that the blockchain operating system is trying to solve here, right? So we are all here in Web3 because we know that there are a number of issues in Web2, such as censorship, right? App Store can take down your application at any time for whatever reasons. And there's also, the lack of, data ownership in Web2, because we all know that, we do not own our data in Web2. Those large corporations own our data, like, Microsoft, Facebook, or Naver in Korea, right? And then on the other side, in Web3, it has its own issues, right? Fragmentation being one of the top issues, because we all know that our ecosystem is very fragmented. Each blockchain has its own applications, its own wallets, its own user experience. And there's very little interconnectivity here. And for example, if you are on Ethereum, you're probably using MetaMask, but if you're using something like Solana, you're probably using the Phantom wallet, right? And a similar issue in Web3 is discoverability. So every time you explore a new blockchain, it will take some time for you to identify all the marquee, real, trustworthy applications in that blockchain that is not a rug pull, right? So that is a big negative in the user journey. And then between Web2 and Web3, they share some common challenges. For example, how do you easily onboard new users, right? How do you deliver the so-called 5 minutes to wow, right? And how do you distribute your product to as many users as possible? And infrastructure management is always a challenge, right? Like if you're in Web2, you're probably dealing with virtual machines, Kubernetes clusters, and so forth. And in Web3, you can leverage the blockchain for your backend, right? But you still need to worry about your front-end services. You probably are still using one of the centralized cloud services like Cloudflare, AWS, GCP, and so forth. So it's never truly serverless, right? It's never truly it's always non-trivial. So these are the problems that the blockchain operating system is trying to address in a more kind of unified way. Next slide, please. And we try to solve these issues by providing developers with all the tools that they might need for building fully decentralized applications. And these tools can be categorized into four different layers in the BOS stack. And there are the blockchain layer, middleware, user interface layer, and the onboarding layer. So let's dive a little bit deeper into the BOS stack. So in the very bottom of the stack, we have the blockchain layer, right, which is the backbone of the Boss stack. And obviously, we have the Near blockchain, we have Ethereum, and probably hundreds of other blockchains. So this is where your smart contract, your trust, your assets, your identity are lying, right? And then on top of that, we have the middleware layer, right? This is a layer of RPCs, indexers, notification services. The goal here is to provide users and developers the same experience that we are all used to in Web 2, right? For example, if you are searching for some data in a search box, you should be able to get a result pretty quickly instead of having to traverse the entire blockchain to get a response. And sometimes this layer is also called the data platform layer because the goal here is to make on-chain data more accessible to users and developers and applications. And then on top of the middleware layer, so we have the user interface layer. This is really the new layers we are introducing with the blockchain operating system. So you can think of it as a new paradigm for developing and deploying your front-end applications. And the way it works is very simple. So essentially, if you have a front-end, you can take the front-end and you can componentize it into a Boss component. This is similar to how you would componentize a front-end using React.js or Vue.js, right? And once you have these front-end components, you can then deploy them onto the Near blockchain. And this is similar, this is similar to deploying a smart contract to a blockchain. So in addition to deploying the smart contract, now you can also deploy your front-end code onto the blockchain, right? And now the full stack will be, on-chain. And once your, the source code of your front-end components are deployed on-chain, right? They instantly become, decentralized, and they are, become unsensible, unstoppable, can be accessed by anyone from anywhere. And also because the code is deployed on-chain, so it is also transparent, right? So anyone can go there and view and audit the source code of your front end, right? So now, in addition to viewing and auditing the source code of your smart contracts, users can also audit the source code of your front ends, right? They can basically audit the source code of the entire stack, which will enhance security. And also, because all the code is on-chain, anyone can view the code and fork it, reuse it, create a new front end based on someone else's front end. And these front-end components, they are individual pieces, so they can be used standalone. However, they also can be composed into a new experience. For example, you can put multiple components onto a single page to create like a one-stop shop experience. And then once you have these front-end components deployed on-chain, we need places where users can discover and interact with these on-chain components, right? And this is where the gateways come into play. Essentially, gateways, they provide access points where users can view, they can browse and interact with all the front-end components on Boss. And it is extremely easy to run these gateways. It can be anything. It can be a website like Boss, near.org. It can be a web app. It can be a mobile app. It can also be like a browser. And sometimes it makes a lot of sense for these wallets and portfolio apps to use the Boss components in their application to extend, to add new features to their existing application without writing a single line of code, right? And finally, on top of the Boss stack, we have the onboarding layer. So this is a layer of products and services that helps you to easily onboard new users to your application. And for this workshop, we are going to be focusing on the UI layer. We are going to show you how you can easily build a Boss component within 15 minutes. Next slide, please. So as I mentioned at the beginning, so our ultimate goal here is to help bring 1 billion users to Web3. And I truly believe that by decentralizing the front-end applications, it actually leads to greater distribution, because now, instead of Uniswap just being available on uniswap.org, the Uniswap component can actually be used, can actually be embedded anywhere, right? It can be embedded in a portfolio app, it can be embedded in a wallet, it can be embedded anywhere and reused anywhere. And Boss really provides all the tools that help developers to build fully decentralized applications, not just the backend, but also the front end. So just in summary, BOSS provides a low-cost, unified development experience for you to build Web3 applications. It has features and services that helps you to build a simple onboarding experience. And developers can also build gateways that provide a one-stop shop experience for discovering multiple Web3 experiences or Web3 applications. And I believe that BOSS is probably the easiest way for you to prototype Web3 ideas, which we will show you in the workshop in a minute. And finally, because everything is deployed on-chain, it's also a open source and transparent ecosystem that anyone can view the source code of both the front end and the back end of an application that someone else built. And this not only enhances security, but also fosters collaboration. And so BOSS is already live. You can actually go to near.org to view an early version of the blockchain operating system. You can see hundreds of components and applications built by other developers. You can easily view the source code, fork them, create new experiences based on these components. And so obviously, BOSS is still in its early stages because we announced it at ETH Denver this year, which is less than 3 months ago. But we already have a number of partners that are building on the BOSS. And I'm just going to quickly go through them. So the first one is Mintbase. So this is an NFT marketplace. So this is their BOSS component. So this can be actually embedded and reused anywhere. Imagine if there's a game, right? The game maker can actually embed this NFT marketplace in their game, right? So that players can easily trade in-game NFTs without leaving the game. And this is another component from Mintbase. Essentially allows people to mass list their NFTs for sale. The next one is Keepom, which is a very exciting project that Matt is heavily involved in the NEAR ecosystem. So it helps to solve the onboarding issues in Web3. So imagine if you want to send another user some crypto, but the other user has no wallet or account set up, right? So what you can do is you can go to Keepom to generate a drop link, and then you can send the user the link, right? And when the user clicks on the link, they will see, so their account will be set up, right? It will be taken care of, and they will see they have received some crypto from you. And this is the Keepom component, which allows you to generate that, those drop links, and it can be embedded in any third-party applications. And we also have NEAR Tasks, which is a platform where users can earn NEAR by completing simple tasks, which is similar to Mechanic Turks, but it's on the blockchain, and they are building a gateway on BOSS as well. And I think finally we have PikeSpeak, which is an on-chain data analytics platform. So they actually have a analytics dashboard component, and you can fork it to create your own customized on-chain data dashboard using based on that component. So I think that's it, and I'll hand it over to Matt to give an awesome demo.
All right, thanks, MJ. So yeah, I just wanted to take the temperature of the room. So like, who's here at ETH Seoul to hack this weekend? Just put your hands up. If you have hands, I only see like 3 hands. Nobody's here to hack? Everybody's here to hang out. Okay, well, any developers in the room who are not hacking? Who's a developer? Put your hand up. Come on. All right. So are you guys familiar with React? You've obviously heard of it. Maybe you built a front end in React. So you're familiar with the concept of components. So basically, you'll start with your top level component. You'll mount that into basically a web page. So it'll, load into the body of the web page. And then your React components will basically unpack into like kind of a waterfall tree, often referred to as like maybe a component hierarchy. So what I'm going to show you today is actually BOSS components. What's nice about BOSS is that you actually get all of the Web3 tooling and all of the sort of wallet connections and even a little bit extra stuff like styled components and a few kind of really popular things like Sass and stuff that you would normally kind of, bring into a React project anyways. So that all comes just by virtue of the default BOSS gateway. It's just all kind of packaged in there. So you'll see in a moment the code that you have to write is actually very, very little to interact with smart contracts on chain. Now for this example, because we're here at ETH Seoul, I'll be talking about BOSS components that talk to basically the Ethereum mainnet. So even though the components are deployed on near.org, they're deployed on the Near blockchain and can be viewed on near.org, they're actually talking to the Ethereum mainnet and Ethereum smart contracts. So if we look at this component right here, I'm just showing you like sort of what the render code would be in a React component. But you can see that there's just very little code here. One thing that's interesting here is I'm actually embedding these widget tags. Now these widget tags are referencing other BOSS components. So I'm showing off basically the composability power of BOSS. And just in a little bit, I'm actually gonna show you how I've embedded another component from another developer. So both of these components came from me, and then I have them in a sort of a parent component called the ETH Seoul demo, but I also have another component that I've pulled in from another developer. So I'm just gonna adjust the microphone a little bit. So I'm just gonna jump over to the code here and basically show you, this is actually called boss.gg. So this is a website that Proximity put together. This is for browsing BOSS components, searching BOSS components, it's for editing BOSS components, and deploying BOSS components. So you can actually edit and deploy BOSS components right inside the web. So basically, this is my ETH Seoul demo. I have just some sort of helper stuff. I can send some messages, fly up a little toast message if I have if I want to communicate to the user like an error or something, just throw up a little bubble. And then basically you can see I'm checking, standard stuff that you would normally do in any ETH app. You check the chain ID, you make sure they're on ETH mainnet, you do all that kind of stuff. And then basically down here, I go to, I'm actually using ethers.js, but this is already brought into the BOSS stack, so I don't have to import it or anything. It's already there. So I can request accounts, and then I can set the sender of any sort of transactions or any request to get balance or anything. There's some style stuff, which I'll touch on in a moment. And then basically down here is that render code that you saw before. So let's take a look at what it looks like. So basically, this is the ETH Seoul demo. So it's automatically pulled in my account. And then it's actually passed the sender as a prop to these other child components. So it's passed it to the ETH balance and also the staked ETH balance, which I'm going to show each individual component in a second. So that's passed down in the sort of component hierarchy, and then you can see they're rendering stuff here, and I can change the message. I can just say like, sender balance. I mean, kind of a trivial change, but basically I can update that. Props get passed down, obviously, to the child component, and it's really just that simple. So in just a few lines of code, I'm interacting with the Ethereum mainnet, I'm reading balances, I'm importing other components, and even this last one down here, which is a fully styled component by another developer at Proximity called Vadim. And this is to stake Ether with Lido. So really cool stuff, not a lot of code. Let's just go back and talk about each one of these components kind of in detail. So in the ETH balance component, this is actually all of the code for the ETH balance component. So up at the top, you can see I check some props. I check basically if the sender has been set in the props. If not, I'm defaulting to my own account just for debugging purposes, things like that. It's really just a few lines of code, it's less than 20 lines of code, and I can go get the ETH balance and I can display it on the screen. And basically, I'm using some of the BOSS APIs like state.update, and when I call state.update and I update state, like basically state.balance, the component will re-render. So all of this VM stuff is sort of handled in a similar way that you would handle with React. So if you were using hooks and you were basically using useState and you were calling setState on a balance variable, for example, you would basically get your component to re-render when you call setState. So a very similar kind of API to React, just a little bit slightly modified. So not a steep learning curve at all. In the staked ETH balance component, I'm just showing one of the helper methods here. I can show the whole component up here. It's basically similar to the balance component, but here I'm loading the Lido contract. So I'm actually pulling the Lido contract from the ETH mainnet. I'm fetching the Lido ABI. So Vadim, when he built his Lido component, he stored this on GitHub user content, you know. So we can pull the ABI in. Using Ethers.js, we can create an interface to the smart contract, and we can actually create this helper method, get staked balance. So we can actually go to the Lido contract on mainnet with our sender passed in as an argument, and we can actually pull the staked ETH balance, and that's going to return that staked ETH balance and do a similar component re-rendering like in the ETH balance example. So once again, though, like I'm talking to an Ethereum contract, right? I've written this on BossGG. I actually wrote these a few days ago, and it really didn't take that long. You know, you basically just kind of look at a few examples, copy over a couple of code, like pieces of code, and then you know I get a friendly little prompt here. Click the preview button. So I click preview, and it says balance is 0 staked ETH. So I haven't staked any ETH with this account yet, but I could. So I could run over to Vadim's component, so he made one, and his is quite comprehensive, and that's because he's actually offered like the ability for you to stake ETH with the Lido component. So it's a little bit bigger, and because it also is like fully styled, so there's a lot of divs, got a little divception here, you know, divs and divs. But basically, this component is kind of like a fully featured way to stake ETH on the Ethereum mainnet. You can go view this component on BossGG, or you can view it on near.org. You can view it through any Boss gateway, basically. And it can also be embedded in other Boss components. So if I go back to the ETH Seoul demo, you'll see that I'm actually just referencing Vadim's component inside my component. So it's right down here at the bottom, and that's all it took to bring Vadim's Lido staking component into my Boss app. So like MJ was mentioning before, you can basically bring in like NFT marketplaces into existing Web3 apps. So you can basically trade NFTs or put them up for sale on marketplaces without leaving the original dApp. So we can have basically dApps inside dApps. We can have multi-chain dApps living side by side on the same page. It's really powerful. And yeah, one thing I wanted to just show, just so everybody believes it's real. I could say I want to stake 0.1 ETH, and when I call submit, the usual stuff happens. Like MetaMask transaction comes up, it's all loaded there. It's ready for me to basically stake this ETH. So yeah, it's really that simple. It's like pretty quick. There's lots of components out there on Boss that you can fork and stuff, and one other thing I just wanted to mention too is that what's really cool about this stuff, I'll look at Vadim's component here, is that as a developer and also as a user, you want to maybe know like which interfaces you're using, and you want to make sure that there's not like a malicious update to a user interface. So sometimes domains get hijacked and basically front ends get swapped out, and contract addresses where you, for example, are sending Ethereum to, they get swapped out, right? So what's really cool about Boss is because these are deployed on Near and they're cryptographically signed by the author that's deploying them, you actually know the code that you're running. So it's really great with Boss. You can version lock, and you can basically load a specific component at a specific moment in time, and you can be assured that you're basically running the right code. So just another cool feature of Boss. The last thing I will mention about the demo here, so I mentioned using another developer's component, is theming and styled components. So I do think this is really cool because I always import the same stuff into every React app, and this just helps you basically quickly theme your components and quickly style them up using familiar stuff like styled components and Sass. Obviously, it's not required to use them, but if you have another sort of like way that you would like to do your styling, but it's all there. It's all just like kind of part of the parcel. So I'm going to pass it back to MJ to talk about our bounty. So this is where you, the 3 developers that put up their hand, can earn money this weekend by hacking on Boss. And you can hack on any blockchain you want. We're just looking for basically components. And yeah, MJ, do you want to talk about the bounty?
Cool. Yeah, thanks, Matt. So yeah, as you've seen, it is extremely easy to prototype and build decentralized front ends using the boss. And we are actually offering, so in addition to all the other bounties that Near is offering, so we at Proximity, we are also offering a bounty for $3,000 for whoever wants to build a decentralized front end using the boss for the liquidity protocol on Ethereum. So if you're interested, we actually have a QR code that you can scan to go to this page where you can find more information about the criteria for the bounty. And another thing I just want to mention that if you're interested in learning more about the boss, tomorrow morning there's actually another talk by Ilya, who is the co-founder of the Near protocol, and I'm sure he has more insights to share about the blockchain operating system. And that's it. That's all from us. Thank you.
All right, next up we have WorldCoin. They'll be doing a talk on global proof of personhood in the age of AI.
Hello, everyone. I'm Penrin. I lead developer relations at WorldCoins, focusing on building with World ID, and I'm here to talk about global proof of personhood in the age of AI. So who in here has heard of WorldCoin before? Quite a few of you, all right. And how many of you have ever built something using World ID? I see 2 hands, which makes me very happy. So, in this talk, I'll go over what World ID is, what World ID does and what it doesn't do, why WorldCoin created World ID, what you should do with World ID, and how you integrate it into your app and can grab your slice of the $20,000 worth of bounties that we have for all the hackers here. So, to start, World ID is here to solve one big question. How do you know who or what is a real and unique person, right? It's really, really tough to know who's a real person, and solving the Sybil problem is a huge issue for Web3, and even in Web 2 as well. It's a useful problem for all of tech, but the solution has its roots here in Web 3. So to solve that problem, we have World ID. It's private, inclusive, and robust, right? Those 3 things are super important because we want as little information as possible about which real human you are, which is a big issue with a lot of other ways that you prove you're human. We want it to be inclusive so that as much of humanity as possible can be a part of the system to prove that they're human. And we want it to be robust to ensure that one person gets one identity in World ID, and you can't have multiple accounts per person. So with past ways we looked at having proofs of personhood, we looked at email and phone, which I've got multiple emails, I've got multiple phone numbers. Not that great of a solution, but is a step beyond just they have an account. We looked at doing KYC on official IDs, but that's very invasive. You're giving up a lot of information about your identity. And less than half of the world has a digitally verifiable identity. So it's not inclusive enough for what we want to do. We looked at webs of trust, but the issue with the web of trust is that every jump further away from that initial core set you are, the less powerful that proof of humanity is. And every implementation of a web of trust so far has had too small of an initial set. And that leaves us with biometrics, which might initially sound invasive, but I'll tell you how we managed to do it in a way that isn't. We looked at a lot of different ways in order to do biometric verification of humanness and uniqueness. Fingerprints and palm scans and face scans were some that we looked at initially. And while those might be good for letting you log into your phone, telling if this person presenting themselves now is the same as this person who presented themselves at sign up is a different problem than determining if this person presenting themselves now is different from every person who's presented themselves to this system before. Touch ID and Face ID on your phone can distinguish about 1 in 30 million people. We need to be able to distinguish 1 in a billion people, right? We also looked at DNA, which highly invasive. It tells you a lot about who a person is. You can determine things like race and sex from that, for example. And that's not what we want. So we settled on iris scans, right? It has a high enough level of entropy to determine 1 in a billion people. It's been highly studied. And additionally, the iris scans that we do make it very hard to passively capture that data, right? People talk about face tracking where, you know, if you're just walking down a street and there's a scanner, it can scan your face. But iris scanning requires a level of attention, which means it requires a level of consent. No one can passively scan your iris in the way that WorldCoin can. And when it comes to that iris scanning, there's a couple different ways that we looked at doing that. We looked at phone sensors, we looked at off-the-shelf hardware, but phone sensors didn't have enough resolution. They couldn't get enough data to distinguish in the 1 in a billion people that we need. Off-the-shelf hardware wasn't trusted enough, it was clunky, it didn't suit our needs exactly. So we settled on building custom hardware, which no one really wants to do. I find it fun personally, but it is like a very tough process. So we settled on the orb, and I have a clear orb here that if anyone wants to look closer at it later, you can. All of the hardware is also open source. And the orb has been in development for a few years. We've gone through lots of different revisions of how we can scan more effectively, more securely. And with the orb, it does a couple things. It makes sure you're real. It makes sure that you're an actual human presented in front of it, not a photo of a human, for example. It checks your iris code is unique. So on the orb device, an iris code is calculated from the photos of your irises taken at the orb. Those photos never have to be stored anywhere. They can be deleted from the orb. If you choose to have them stored, it's entirely opt-in. And if you have them stored, it means that if we upgrade the algorithms in the future, you don't need to be rescanned, but again, entirely opt-in. And with this process, it verifies your World ID, your self-custodial identity, currently available in the World app, which is the app that WorldCoin has created and put out into the world. World ID is sort of like a global digital identity, it is a global digital identity protocol. It's somewhat like an internet passport, right? You have your proof of personhood credentials. Right now, you can verify yourself at the orb. We consider that to be the gold standard. It's a very strong proof of humanness. Or you can verify with a phone number if an orb isn't available in your region, for example. And in the future, we'll be adding support for more forms of these proof of personhood credentials. For us, this proof of personhood is a spectrum, right? It's not you are a human or you aren't a human. It's how likely is it that you're a human? How sure can we be that you're a human? So, for example, if someone's phone verified with World ID, perhaps you give them $1 of free credit, whereas if they're orb verified, you give them $10 in free credit. We designed World ID to be privacy first, decentralized, and open source. WorldCoin has to collect no identifying information about who you are. Your phone number is not required. We never ask for your email. We have nothing about your name or who you are. Decentralizing is an important part of what we're doing. While orb verification is something controlled by WorldCoin, at the moment, we are going to be opening up the protocol to other companies' forms of humanist verification in the future. And it's open source. IDKit, our front-end widget, is open source. Our smart contracts are open source. And for the things that aren't yet open source, we are always working to open source them when we can. And there's a lot of different things you can use World ID for. It's really useful to know that a user is a unique human in a lot of different circumstances. Voting is a great example. You can make sure that one person gets one vote instead of one wallet address gets one vote or one token gets one vote. You can have a very fair system. For social media, everyone wants to know who's a real human and who's not. We've all seen what's happened with Twitter and how Twitter Blue and verification has changed drastically. But a system where you know this is a unique human behind this account. but they can still be an anonymous account. They don't have to give up their real identity. You just know it's a real human. Customer incentives, I already talked about. You can give a little bit of free credit for someone who has a lighter proof of personhood, or a lot more free credit to someone who's been orb verified. Events, you want to know that it's real humans signing up and not bots. Tons of different use cases, and if anyone wants to talk about what your use case might be in the hackathon, I'm happy to chat with you at our booth after this talk. And we designed World ID to be super easy to integrate, both for Web 2 and Web 3 use cases. You can use World ID on the web, you can use World ID on your mobile device, you can use World ID on chain. And there's two main ways to use it. You have sign in with WorldCoin and anonymous actions. Let's start with sign in with WorldCoin. So who here has used ChatGPT before? All right, I see a few hands. I think it's actually more people than raise their hands, but I won't say anything. And when you sign into ChatGPT, it uses Auth0, right? So you can sign in with your email, or sign in with Google, or sign in with your Microsoft account, and very shortly, you could potentially, hopefully, sign in with WorldCoin. When you sign in with WorldCoin, you tap the button, and it takes you to our page. You see a QR code, it's very simple. You scan that QR code from your phone. You can go in the camera app, or you can scan it from the World app, and it pulls up this modal that asks you to approve your sign-in. It tells you what you're signing into, if it's a verified app, and then you're signed in. Now, if you want to integrate sign-in with WorldCoin, there's a bunch of different ways. Auth0, as I mentioned. There's NextAuth. You can use the OIDC well-known file with another provider, build out custom OIDC flows. But for now, let's focus on how you would integrate it with NextAuth. This is all you need to integrate World ID with NextAuth. When you configure your NextAuth provider, all you have to do is fill in this information, set the World ID application ID and your client secret from the OIDC provider, and then it works. It's super simple. NextAuth has made this incredibly easy, and this is all it takes in order to integrate sign in with WorldCoin into your app with NextAuth. Specifically, if you're interested in using sign in with WorldCoin, we have a $3,000 bounty for the best sign in with WorldCoin use case. And now let's talk a little bit about anonymous actions. Anonymous actions are a little bit more complex than sign in with WorldCoin. Anonymous actions let you prove that you're a unique human doing something once with a specific signal, although the signal is only supported on-chain. So what does this mean? When you do an anonymous action, you get that verification that a user's human, and you get to know which verification method they've used, if they're phone or orb verified. You get to know that they're doing something once, because every time the same user takes that same action, it will generate the same nullifier hash. That nullifier hash is sort of that unique identifier for that combination of user and action. And the signal for on-chain use cases is part of that zero-knowledge proof generated on a user's device that will make sure that the information they wanted is part of that proof. That can be their signal in a vote, who they're voting for or what they're voting for, or if they're claiming an airdrop, that can be their wallet address. It ensures that that is part of the proof and hasn't been tampered with. So to integrate sign in with WorldCoin, everything starts with IDKit. So IDKit is the component you can use in your React front end. And this is all you need. Oh, wait, I'm sorry. This slide is not supposed to be in here. Sorry. It all starts with IDKit. IDKit is this modal, right? The one where the user scans the QR code. This is all it takes to integrate IDKit. It's one component. You have to pass it your action name, your app ID, the function that you want to call once a user's verification has been returned to your app. That's on success. Handle verify is optional, but I can explain a little bit more about that later. And you give it which credential types you want to accept for this. So you can limit it to only people who are orb verified, only people who are phone verified, or people who have either one. You have a single button that opens IDKit, and on your front end, that's quite easy. But you have this response from IDKit that gets passed back to your app. Your Merkle root is saying which Merkle root that user has been validated within. The nullifier hash, again, is that unique identifier of that user and action combo. The proof is this very long hexadecimal string from semaphore that actually is the zero-knowledge proof, and as well you get the credential type they're verified with. But you have to do something with this. Just having someone verified on the front end alone is not enough to know that they're a real human, because people can manipulate things in the front end. You still have to verify the proof. You still have to verify the proof. You still have to verify the proof. I want to make that super clear, because if you don't verify that proof anywhere, you're not eligible for the bounties and you haven't integrated IDKit correctly. I just want to make it abundantly clear that you have to verify that proof. And how do you do that? So one way you can do that is verifying it with the WorldCoin API. We have an endpoint, the API v1 verify endpoint with your app ID at the end of that. You simply pass it all of the information that you got from that, from IDKit, that Merkle root, that nullifier hash, that proof, and the credential type. And then you'll get a response from our API that says, yes, this user verified, or it will return an error code indicating why they weren't verified. That can be that the Merkle root was invalid. That can be that they've already verified for this action before. In the developer portal, for the API verifications, you can set an arbitrary number of times you want to let a user perform a certain action. You know, oftentimes that'll be a single time you want to let them do that. Sometimes that'll be an unlimited number of times you want to let them do that. But if you want to let a user do something 3 times, say you're a social media platform and you want a user to be able to have, you know, a doxed account, an anonymous account, and, you know, a third account just for whatever they want, you can let them verify up to 3 accounts, but only 3 accounts. But what I'm sure most of you are interested in is how to verify proofs on-chain in your hackathon projects. So when you want to do on-chain verification, you have to instantiate the World ID instance. So you pass it the address of the World ID contracts. We have ENS addresses or ENS domains that resolve to those. You can find those in our documentation. And then your app ID and action ID. So then you have to create the external nullifier by encoding and hashing the action ID and app ID together. And then you have that instantiated. And then to actually verify that proof, you call the verify proof function on our smart contract. You pass the Merkle root, the group ID, which will be 0 if you want to check if a user's phone verified, or 1 if you want to check if a user is orb verified. You give it the encoded and hashed signal if you want to. If you aren't looking to use a signal, you can leave that as an empty string. You give it the nullifier hash, the external nullifier, and the proof. And then it will revert if the user cannot validate, if they've already, if any part of that doesn't validate properly. But if you want Sybil resistance for your Web3 on-chain verification, you have to handle that yourself. And we see that here. So if the nullifier hash is already in the list of nullifier hashes, we revert because we know that they've already performed this before. But if the proof verifies, the next thing we do is add that nullifier hash to that list of nullifier hashes so that we basically check the box that, yes, they've done this action before. So for the hackathon, as I said, we have $20,000 in prizes. We have $5,000 to the best overall project, $3,000 to the best governance use case, $3,000 to the most creative use case, $3,000 to the best sign-in with WorldCoin app, 3 $1,000 honorable mentions, and a $3,000 prize pool for any project that properly integrates World ID or sign-in with WorldCoin. So our SDK is currently still invite-only. If you'd like to get access now, please scan this QR code or go to the link on your computer. If you don't grab this now, you can also come ask at our booth. And then I'll give everyone a minute to scan it who wants to. I still see a few more phones. All right. And then at worldcoin.org/soul23, you can see a Notion page that we've compiled with lots of information and resources about what we're doing here at ETH Seoul. So you can see the bounties there. There's links to our starter kits, both for on-chain and off-chain use cases, all our documentation, blog posts that dive further into how World ID works, and our FAQ. And that is how to integrate World ID. So I figure I'd also give you all a quick demo that should hopefully work. We did just update our simulator. So for production use cases, right? Actually, perhaps I should start with the developer portal. So the developer portal is at developer.worldcoin.org. You have to sign in with WorldCoin for this. I don't have a cable to connect my phone to my computer, otherwise I would put it up on the screen as well. But to sign in with WorldCoin, all I have to do is scan this QR code. It opens up the modal within the app, as I showed earlier. It's waiting for my phone to finish. I just tap verify with World ID. Proof is generated on my device, sent over to the ID kit front end, and we are now logged in. So with the developer portal, I can create an app. I can just name this Seoul Demo. The description is optional, but there's two things you have to choose here. You have to choose if it's staging or production. So if it's a staging app, proofs will only validate if they come from the simulator, which you can find at simulator.worldcoin.org, or production apps, which will only validate with proofs from the app, the World app on a user's device. So we'll go with a staging app, and then we have to select cloud or on-chain. So cloud actions you verify with the API, or if you want to do sign-in with WorldCoin, you'll also create a cloud app. On-chain, you can only validate on-chain. So we'll go with a cloud staging app, for example. I'll create this new app, and then from there, I have to create an action. So I'll create a new action. Let's just say verify at ETH Seoul. You have to give a description that explains what you're asking users to verify in order to do. So let's just say test here. It creates your action identifier. This is what you will pass to ID kit and pass on chain. And then you can select how many verifications you want to allow. So I can say up to 5, I can say 100, but for this, let's just go with unique, only letting a user verify once. So I create my action. Why is it not working here? Let's see if it didn't like how short my description is. All right, let's refresh the page and try again. And now we've created an action. So if I wanted to go ahead and integrate this into my app, I just have to set the app ID and action ID in my environment variables. So you can do that in your local.env file. You can do that in your Vercel environment. Basically, that just has to make sure it gets into ID kit. So I put together a brief demonstration of using World ID for an off-chain use case. I wanted to let people claim a free item from a Shopify store, and they get a more valuable item if they're verified with an orb, or a cheaper item if they're verified with their phone. So let's see if the simulator is working properly. Once ID kit comes up, if you're testing with the simulator, you can actually just click on the QR code to copy that. To get that over to the simulator, you'll insert your QR code manually, paste that in there, hit submit. This has been sitting here for a bit, so I bet I just need to refresh the simulator. Or do I need to log out and start from the beginning? Well, let's start from the beginning in the simulator. So when you start from the beginning, right now the only chain that the simulator works on is Polygon Mumbai, but as we will be transitioning to Optimism in the near future, very shortly you'll be able to also do this on Optimism. So I can either generate a persistent ID where I would sign in with a wallet, but for this, oh, I took myself back to where I was. For this, we will create a temporary ID. So I click this, it takes a second, but it will take me into the simulator. And I'm not verified right now. I am not verified with the phone, I'm not verified at the orb. So I can click verify my identity. Let's start with phone number verification. So I click verify, this is a fake phone number, but now you can see that I'm phone verified. So if we take this QR code and insert it here, this might not work because it typically takes a couple minutes for that identity to be inserted on chain in order for the verification to work. But I have put in the QR code. I'm going to verify with the phone. It knows that the verification hasn't been put in yet. I'm going to try continue anyway and see if it works. It appears that it did, but the success is just called once IDKit has returned everything properly. This does not mean that the proof is verified on the back end yet. So if I click here, it appears that it did not work, unfortunately. That's all right. I can show you another example of what it does look like when it works properly. So we go to try it out in the docs. And let's do a staging app. Let's separate these tabs, and we'll open up the simulator in split view here. For the action, let's just say ETH Seoul. We want to accept phone credentials. Continue with WorldCoin. Oh, we need to update IDKit in the docs because it doesn't have the click for the QR code, unfortunately. That's unfortunate. Let's go with production just so I can demo this on my phone again. Let's go with orb verification because I am orb verified on my phone. I scan. It's waiting on my phone. Verify with World ID, and it's successful. So that's a brief overview of how you can use the simulator or how you can test it out in the documentation. In the docs, there's lots of information about World ID overall, how to use IDKit specifically, how to use our API, how to do things on chain. And as always, if you have any other questions, you can reach out to me at our booth here. You can reach out in the WorldCoin Discord. And yeah, I'm always here to help you build on World ID here at the hackathon. Thank you.
All right, next up we have Ryan from Lightscale. He'll be doing a talk on Chroma, integrating ZK EVM on optimistic rollup.
Hello guys. Have you enjoyed ETH Seoul so far? Great. I'm Ryan, and I'm a blockchain lead at Lightscale. And before starting, I should say that I have, maybe the organizer and Erica noticed that the presentation changed a lot. I tried to make sure that presentation, I tried to deliver the key message in a very easy way for you to understand, and because I practiced in front of teammates, and my teammates complain about it's too hard for audience to understand the content. So I practiced a lot, and I changed the presentation in a way to understand the key points, right? So I'm gonna start the presentation, and I'm so excited to talk about a Chroma on new layer 2 network, but I believe most of you may not have heard of Chroma before, so I prepared some questions to help you understand. So So is Chroma an optimist rollup? Do you guys know? Yes. Does Chroma use GK-EVM? Yes. And you can think of Chroma as a combination of optimism and scroll GKM. And why is that? I will tell you the reason why we combine this tag later. And I think that mixing the scroll, I think that it is very hard to integrate GK-EVM into optimism. It's kind of hard to me, but in result, it's not that hard that it sounds. I tell you the modification part later, and you think that not that much part is modified in the result. So in today's presentation, I will cover these three main topics. One is that what we have changed to optimism and GK-EVM circuit. And please do not fear. And as I said before, I'm gonna deliver the key points in a way that is very easy to understand. So please don't leave. And finally, I'm gonna cover why we start our chain from optimist to rollup and how to transition to our chain to GK rollup in the end. So optimism consists of these 5 components: L1 contract, L2 contract, L2 node, OP-get, and canon for fourth proof. In the case of Chroma, it consists of these 5 components: L1 contract, L2 node, Chroma get, and GK-EVM. And for our purposes, we have mainly changed these 4 green highlighted parts. But today, I'm gonna talk about these 2 highlighted parts. So let's go to the change to optimism. So before going deep dive into what we have changed, let me show you how the optimist rollup works. In this diagram, which I taken from the optimism blog, it says it is composed of L1 and L2. Rollup uses state transition function, for short, STF, to compute state or change the state, and then it submits the transaction as a batch and state commitment to the layer 1. And it shows that it seems that like the submission happening every L2 block, but in fact, the submission happens in the periodically. So many L2 blocks are bundled together and submit as a batch. So the term is rollup. And here, state commitment plays a very crucial, important role in withdrawing funds from layer 2, because if an incorrect state root is submitted to layer 1 and nobody challenges against it, the whole funds deposited L2 could be lost. So someone has to challenge against the incorrect state root. So to submit the proof, to submit the challenge, you need to run the state transition function locally, right? And to do that, you need to derive the state based on the transaction from submitted to layer 1, right? And in order to do this, so you download the transaction and you run the state transition function. And once you collect the proof and you submit the proof and challenge to the layer 1, the contract should run the proof float function, or more recently, we refer to as proof float function. The layer 1 contract should run execute at the transaction to determine the outcome of challenge. And in order to run the function, you need the 2 ingredients, which is, as you can see, state 2 and transaction 2, which is the previous state and the transaction for the next block, right? Please take note that we need to it is required to access both previous state and transaction. So proof or function, as I said before, you need the access to state and transaction. State is very easily to be obtained. You can obtain the state from state root and corresponding Merkle proofs. Then what about the transactions? If you take a look at the architecture of optimism bedrock, there are two submitters. One is batch submitter, and the other is output submitter. And batch submitter compresses transaction and submits the transaction as a batch and via a core data to EOA, which is called batch in box. But in the case of state root or state commitment, the output submitter submits it to the contract. But for contract to read the transaction, it is impossible for contract to read the data from core data of the previous transaction. It only accesses the data from the core data of the current transaction, right? So in order for contract to read the data from code, in order for a contract to read the transaction data to run the state transition function, we need to come up with some alternative way to do this. So we need to make a choice between either change the destination of the transaction from EOA to contract, or we need to somehow figure it out to retrieve the transaction from contract, state commitment. In our case, we don't want to increase the cost of, we don't want to increase the cost because of the challenge, because considering that challenge happens rarely, right? You don't even have a chance to watch the challenge happening in layer 2. So we decide to retrieve the transaction from state commitment. In the case of optimism, they use upload as a state commitment. They submit upload, and it is composed of version, state root, withdraw storage root, and block cache. And nothing can be helpful in terms of retrieving transaction. So we include next block cache when computing upload. In this way, by submitting pre-images to upload, you can retrieve the transaction. So in the case of Chroma, when you submit the state commitment to the network, it contains next block cache in the state commitment. By providing transaction root and Merkle proofs and next block cache, upload, and the pre-image, now you can obtain all the ingredients to run the state proof. Wow! So let's switch. Okay, so and in typical optimist world, there are two levels of interactions. One is block level interaction, and the other is instruction level interaction. And in the case of Chroma, we eliminate away the instruction level interaction because all we need is just the block cache, just transaction and previous state. And what even makes me more excited is about this architecture. Once the future development technology such as proof recursion is applied to our case, then whole interaction could be got away. So once you manage to produce a proof, you just submit the proof, and then you can know the outcome of the challenge. It's amazing, right? And I'm going to show you how the block interaction happens at our chain shortly. And before that, I'm going to define two participants here. One is asserter, and the other is challenger, to help you understand what's going on in the next slide. And asserter is the participant who submit the state commitment to the layer 1. The reason why we name asserter, because he asserts some certain state transition is correct, And the challenger is the participant who raised objection to an incorrect state commitment. So our challenge always starts with challenger and ends with challenger to make sure for him to submit the fourth proof. So in this case, challenger needs to submit this much state commitment to the network. And he needs to submit the state commitment in units of 4 blocks. The reason why he submits such like that, this is because if you submit all the state commitment which is required for challenger to the network at once, it might exhaust the whole block gas limit, right? So he submits something like that. And if an asserter detects some challenge is going on, then he needs to find the first mismatched state commitment from the state commitment submitted to the network. And in this case, fourth state commitment is different. So it needs to submit the whole state commitment within that interval. And then, similarly, challenger needs to submit the rest of, needs to find the first mismatched interval and needs to submit the rest of state commitment to the network. In this way, both of them can agree with one step of single state transition, and now it's ready to run proof of function. This is how the challenge is going on in Chroma, and let's switch to the perspective of GKEVM. And GKEVM is a very complex program, even for me, but if you take a look at it very simply, it's a program to produce proof based on an input called execution trace. And the GKEVM introduced the concept called type, and our GKEVM is based on scroll, which is type 2.5, so which targets to EVM equivalent. So what this means is that if your solidity, if your contract is developed to be deployed to Optimism or layer 1, you can deploy your contract to our chain without any significant change, which provide you with compatibility and ease of adoption. And GKEVM produces a valid proof only if the state transition follows EVM specification. But to GKEVM, in our case, he doesn't know about some custom parts which is derived from Optimism. So we need to let him know what's unknown to him. So in this case, you can think like the 2 points are different. And one is the derived from custom transaction called deposit transaction. And the other is fee collection, because the L2 needs to submit the transaction or state commitment to the network, right? So the layer 2 needs to collect the fee from user, right? So deposit transaction differs in a way that it may meet if, and it doesn't provide a tip to Coinbase, and it computes something called source hash, and it doesn't involve in signature verification. And fee collection for transaction other than deposit transaction, it differs in a way that it collects L2 base fee, it doesn't burn base fee, and it collects world fee based on Aaron base fee. So we need to let him know these unknown points. And we did it very simple way. So Scroll GKEVM is based on PSC GKEVM, and they mainly have changed this red highlighted part. And in the case of Chroma, we mainly changed these two parts. One EVM circuits to handle deposit transaction and fee collection, and transaction circuit to handle deposit transaction. And the current event circuit is composed of these many circuits. It is always start with begin block step and it ends with end block step. And for each transaction, it always starts with begin transaction step and it ends with end transaction step. And to handle deposit transaction in EVM circuit, we have introduced begin deposit transaction and end deposit transaction. And to handle fee collection part, we have added base fee hook and roll-up fee hook steps. And yeah, there's not much difference, right? And in a typical transaction, it involves in computing two kind of hash operation. One hash is used to verify signature. The other is used to compute transactions root. And in case of EVM circuit, this kind of operation is handled with the way called lookup. And in the case of deposit transaction, as I said before, it doesn't involve in signature verification, and it computes something called source hash. So in the typical transaction, like transactions other than deposit transaction, we can reuse the transaction circuit. But in the case of deposit transaction, we need to replace the transaction source hash values with some parts related to transaction sign part. Yeah, that's done. With these two modifications, you can combine GK-EVM on top of optimism framework without that hard engineering cost. In the end, I'm going to talk about why we start our chain from optimistic rollup and how we are going to transition our chain to GK rollup. So we think that at this moment, proof generation cost and time is expensive and slow from the practical perspective, but we believe that GK rollup is the future. So there will come a time that to overcome all the limitations I mentioned. So we design our chain to be easily transition to GK rollup. Let me show you what I mean. So does Chroma plan to be a GK rollup? Yes. And do we need a state migration? No. Why is that? Here, if I refer to state migration, it means do we need whether moving the leaves from MPT to leaves of GK-friendly tree? In our case, we don't have to, because state is already represented by GK-friendly tree. So when we transition our chain to GK rollup, there's no pause time. It could be transitioned to GK rollup smoothly and without any halt. Amazing, right? And let me share our status and plan. So we launched our testnet in the last quarter, and we are now operating the testnet. In the next quarter, we are going to launch mainnet for Optimus Raw version. In the last quarter of this year, we are going to launch GK Raw testnet. And the second quarter of next year, we're going to launch mainnet for GK rollup, facilitating the transition, the chain. Yeah, of course, there are many challenges and there are many concerns to be solved, but we are committed to serve one by one, so please keep an eye on our progress. And let me wrap up the presentation today. So I just talk about what we have changed to optimism and GK event circuits. To verify for proof in the layer 1, we need to access transaction. And to do this, we modified upload so that we can retrieve the transaction from it, and we are able to run the verify function. And to let the GK event circuits know the custom parts derived from optimism, we have changed mainly two parts of circuit. One is event circuit, and the other is transaction circuit, to let him know the deposit transaction and fee collection part. And in the end, I just said before, our chain is optimistic rollup, but we plan to transition our chain to GK rollup and without any state migration. Additionally, we are nowadays working on validator decentralization because we think that in the context of blockchain, decentralization part is very important. So yeah, that's what we are doing right now, and we are going to be audit in the 2 weeks later. In the end of June, and after that, in the short term, we are going to implement account abstraction. In the long term, we also want to or plan to decentralize the sequence part using T-based PBS. So thank you for listening. If you are interested in what we are going to do, then you can follow up any links here, and you can scan the QR code. And I always be there, so you can feel free to come to me and ask what you're curious about. And thank you for listening.
All right, guys, dinner will be served at 5:30, and the opening ceremony will begin at 7 o'clock. So we'll see you there. Thanks.